Hey guys, I hope you're doing great today. Well, there is another course coming along your way, and it is AWS Cloud Practitioner Certification course. Guys, in the previous course, we covered about Azure fundamentals, and we also discussed how we can pass the Azure AZ900 fundamentals. In today's course that we are going to begin with is about AWS foundational certification, and it is known as AWS Cloud Practitioner Certification. So I have already prepared all the lectures, as you can see, on my Google Drive, and I promise I will share each one of the lectures. So keep checking out the description of each video because I share the relevant information about any topic or any video in the description. So first of all, I'm super excited that we are going to complete this course as soon as possible because then we are going to proceed with AWS Certified Solutions Architect. And then that course would have a lot of practical stuff. So theoretically, we have to make sure that our concepts are stronger so that we can move along with other AWS services when we are going to cover AWS Solutions Architect. So let's get started, and this would be an overview of the course. Okay, and we are going to cover each chapter one by one. As you can see, there are around 11 chapters, just like we have 13 chapters of AZ900 Fundamentals course, and we will have 11 chapters. And if you know about the AWS basics, you know about the AWS services, then you are going to pass the AWS Cloud Practitioner Certification exam. The exam consists of 60 questions, okay? 60 questions, and you have to answer all those questions in a given time, which is 100 minutes. And 700 marks are the passing marks that you have to get to secure AWS Cloud Practitioner certification, and it is one of the foundational certification. Let's get started. And before we get started, make sure that you have subscribed DevOps Molvi. I really appreciate your support. So, what we are going to have in our chapter one, and it is AWS Cloud Practitioner Certification course overview. So, without any further ado, AWS Certified Cloud Practitioner Certification and its overview. The AWS Certified Cloud Practitioner validates foundational, high level understanding of AWS cloud services and terminology. From terminology, I mean to say, what is an AWS region? What is EC2? What does S3 stands for? What are the types of storage in AWS? Okay, what is Route 53? What is an IAM policy? So these are all terminologies that we must know in AWS foundational certification. And the AWS Certified Cloud Practitioner certification exam is $100. Okay. And if you want to get a free voucher, I have already created a video for that, and the video's link would be in the description. You can try it. So this exam would be for $100. I got a free voucher and I just gave it a try and I passed it in my first attempt. Cloud Practitioner certification is considered one of the easiest certification online because it is very basic. You have to know the basic AWS concepts. You have to know the foundational AWS concepts, and it is great starting point for beginners who want to learn about AWS. So if you are going to start your journey for AWS, you want to learn AWS, you must know the foundational concepts of AWS, and that's what we are going to cover in this course. After that, guys, what is AWS Cloud Practitioner Certification? The AWS Certified Cloud Practitioner Certification is an entry level certification. Okay, it is a foundational level certification. Still, it costs $100 and it is designed to validate a basic understanding of the AWS Amazon Web Services cloud platform. After completing this course, I hope that you know a lot about AWS services. You will know about AWS CloudWatch. You will know about AWS compute services, storage services, DNS services. And what we are going to cover in this course, we are going to know about what is AWS, AWS compute in the cloud, AWS Global Infrastructure, in which we are going to discuss about AWS Regions, AWS Availability Zones, and AWS Edge Locations. We are also going to cover about AWS networking like virtual private cloud, Route 53, etc. And also we are going to cover about storage, simple storage service, instance store, elastic block store, and also about the databases like Amazon Aurora and Amazon DynamoDB, which is a relational and non-relational database, and also the key services of AWS security like identity and access management, Amazon Inspector, Guard Duty, AWS Shield, etc. And after that, we will cover about monitoring, how we can monitor our infrastructure in AWS with the help of services like CloudWatch and CloudTrail. And the last chapter would be pricing. And in pricing, we are going to discuss about the AWS pricing calculator, AWS pricing model like pay as you go, and also about the support plans like basic support plan, enterprise support plans, etc. So guys, I will see you in the next chapter. We are going to talk about what is AWS. So make sure that you have subscribed DevOps Molvi. I will see you in the next chapter. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 2 of our AWS Cloud Certification course, and it is about AWS. What is AWS? The big picture. So we are going to get a clear picture of what is Amazon Web Services. What is AWS known for? So let's get started and make sure that you have subscribed DevOps Molvi. I really need your support. So guys, what is AWS? Starting with the first slide, AWS, short for Amazon Web Services, is a comprehensive cloud computing platform offering a wide range of services, including compute, storage, databases, analytics, and more. AWS is the world's number one cloud platform. Yes, that is true. AWS is still the number one leading cloud platforms in the world. AWS has now many competitors like Azure, Google Cloud Platform, Oracle Cloud, DigitalOcean, Linode, Akamai, and IBM Cloud, but still AWS is the number one as per the market share. AWS has the world's largest customer base in the world, and it has regions around everywhere now in the world, and it is still expanding and spanning its regions and data centers around the globe. So there are 200 plus, okay? There are 200 plus services that are offered by AWS. These services can be like compute, storage, analytics, databases, and security services. So I used to say that AWS is one-stop shop for everyone. If you want to have any kind of application hosted or running on AWS, AWS will guide you through the best possible way. If you want storage, AWS has got unlimited storage. You want compute capacity, you will get a number of different instance families on EC2 that can fulfill your all compute needs. If you want to have databases, you can get the fastest and super fast database services like Aurora for relational databases. DynamoDB for non-relational databases. And similarly, AWS has security services like identity and access management, Amazon Shield, Amazon Guard Duty. If you are looking to run your applications, if you are looking to run your code on AWS, AWS has DevOps services, AWS has container services, Kubernetes clusters, and everything. Okay, it means that if AWS is offering 200 plus services, then definitely it is obvious that AWS has covered around every field like AI, machine learning, compute, storage, and so on. So AWS is big. AWS is the world's largest cloud platform till date, and it is still dominant. Though there are so many competitors, but AWS is at number one. So that's why the AWS certifications are important for your career. And if you are going to choose cloud engineer as your career, if you're going to choose security engineer, cyber security, or DevOps engineer, site reliability engineer, AWS is one of the most hottest skills, I would say, or cloud platform that is required in every job posting. I mean to say that you must know AWS services, you must have worked on the key and major popular AWS services. These certifications will make your resume stronger and stronger, and you will stand above in the crowd. Amazon Web Services is the world's most comprehensive and broadly adopted cloud, offering over 200 fully featured services from data centers globally. Now, there are 200 plus AWS services offered by AWS. AWS has regions around the world. It is still expanding its physical infrastructure. I remember that it has 36 regions in different parts of the world. It has over 100 plus availability zones and hundreds of data centers and edge locations. Don't worry, we are going to discuss about AWS physical infrastructure in our upcoming lecture. So that was actually the big picture of AWS. Now we know that what is AWS. AWS stands for Amazon Web Services. Amazon Web Services is a collection of 200 plus cloud-based services that you can use to run your code, your applications on all those AWS services. And the major ones are compute, security, storage, databases, AI, and machine learning services. The list is huge, okay? So now we are going to discuss about AWS services here as well. AWS is separated into different services. Each can be configured in different ways based on the user needs. So for instance, if I am a new user and I just want to have a virtual machine running on AWS, AWS has the solution. I can run my virtual machine using EC2. If I want to store data, okay, I need a data bucket, then I can definitely use S3, Simple Storage Services. If I want to have a database on AWS, then I can use Amazon RDS. Okay, so I have the choice to use the service that is offered by AWS. Amazon Web Services offer more than 240 fully featured services till date. Okay, AWS keeps adding services more and more and more. Okay, now till date we have around 240, which is a huge big number of fully functional, fully featured AWS services. 240. Now, what are the most popular AWS services we have? We have compute, okay, EC2. We have storage, like Simple Storage Service or EBS. We have databases like RDS. We have governance, okay. We have AI and ML services. And we have mobile development services that are most popular AWS services. Don't worry, we are going to cover them one by one in our next lectures. As we move along, we are going to have a detailed look at each one of the services. Now, there must be a question in your mind that whether AWS offers DevOps services, because me or you being DevOps engineers, we must know that whether AWS offers DevOps services, and the answer is yes. These are actually the DevOps services that are suitable for all DevOps engineers, software engineers, and software developers as well, like AWS Cloud Build, Continuous Integration Service, CI, okay? AWS Code Pipeline, which is a CI/CD pipeline on AWS, Code Deploy, which is Code Deployment Service, Elastic Container Service to run containers, Docker containers on AWS, Elastic Kubernetes Service to run Kubernetes cluster, managed Kubernetes clusters on AWS, and AWS Cloud Formation, which is infrastructure as code like Terraform on AWS. So these are the key AWS DevOps services that we must know as a DevOps engineer. So guys, now there is one of the key concerns that every student should have, whether I can start learning AWS for free. I don't have to spend a dime. I don't have to spend a rupee on AWS services, and I can learn the cloud platform for free. I can learn AWS for free. And the answer is yes, you can get started learning AWS for free. There would be no charges because Amazon offers a free tier known as AWS free tier. Here is the link that we can go through, and we will go through this link to know more about AWS free tier. So there are actually three types of offers that AWS has in its free tier. More than 100 AWS products are available on AWS free tier today. Now it means that 100 plus AWS products are for free to use, and you can learn. That would be actually enough for us, okay? If I have 100 plus products for free to use, then definitely it would be enough for me to learn and to know about AWS. And the good news is that those services that are important from my career perspective, that are important from DevOps engineering perspective, all those key services are totally free. Like AWS EC2 is free. S3, you can run it for free. IAM, that is free for the rest of our life. So don't worry, the services that I am concerned as a DevOps are totally free. There are three different types of free offers that are available depending on the product used. And click an icon below to explore our offers. Now this is just a screenshot. We are going to visit this link. So we have free trials, we have the services that are free for 1 year, and we have the services that are free for the rest of our life. So there are actually three types of offers in AWS free tier. The services that are only available on a limited basis, we can have only the free trials, okay? Then the services that are free for 1 year, okay? And the third is the services that are available for the rest of our lives. And these are three types of offers in AWS free tier. So we are going to discuss how we can sign up for free on AWS in the next chapter. But let's click on this link and let's see what we have in AWS free tier. So we can create a free tier account from here. That's the same process we are going to discuss in our next chapter, how we can sign up for free on AWS. I will discuss the requirements that are needed to sign up for free on AWS. Gain free hands-on experience with AWS products and services. So now you can see what are the free trials. Okay, I am going to open it in the next tab, and we will have these services as free trials. Okay, now you can see we have Amazon SageMaker AI, free trial for 2 months only. We have Amazon App Stream Service 2.0. We can have 40 hours per month of Windows Stream standard large image builder usage. So that's how we can learn about the trials. We can learn about what are the services that are free for 1 year, for 12 months. And also I will uh, open this to know which services are free for the rest of our lives. Now you can see that these services are for 12 months free. Okay, 12 months free. And in this free trial, you can see we have free trial. We have free trial for this service. It means that these services are not free for 12 months. Your trial finishes, then you're done. You have to purchase, you have to pay for the next usage. And these services are for 12 months free. It means that these are available for 1 year to play with. And I think that that would be enough to learn about AWS. 1 year is enough. So all these services are available for, sorry, for 12 months free. And now talking about always free services, I will go through this tab, and now you can see here these services are always free. Free tier Amazon DynamoDB 25 GB of storage would be free for the rest of our life. So we can have this Amazon AWS Lambda 1 million free requests per month, and it is always free. Similarly, we have other services that are always free, like Amazon Aurora Distributed SQL, and we have 100K DPUs that are always free. We have Amazon Q Developer, always free. We have this as 12 months free. So if you click on this link, I will definitely share it with you guys. You can see it in the description. You can know about more detailed information about the AWS free tier. And now after that, we can navigate to databases. All the database services will pop up. Okay. And I can then go to storage. I can navigate according to the service, to the solution that I'm specifically looking for. For instance, if I want to run containers on AWS, then I can navigate to containers. Okay, I will click on here, and now you can see we have Lightsail, we have Elastic Container Registry, we have ECS Anywhere. You can see free trial for 2200 hours. Similarly, more information about machine learning. Okay, you can see here these are some of them are free trials, and some of them are for 1 year free. And that's how we can learn about the AWS free tier. It is aws.amazon.com/free, and it will share us every information about the free tier. So that's it, guys, for today's lecture. And I hope that you know about AWS, you know about the major AWS services, and how we can get started with AWS for free. In the next chapter, we are going to sign up on AWS using our debit card. I will let you know how we can sign up on AWS for free. I will see you in the next chapter. Take care. And if you have any suggestion, feel free to let me know. Have a good one. Bye. Hey guys, I hope you're doing great today. Well, this is our third chapter of our AWS Cloud Practitioner certification course. We know that, and we have already discussed that AWS Cloud certification is the foundational certification to get your journey started with AWS. And then after that, we are going to cover AWS Solutions Architect course, and that course will involve a lot of practical stuff. So, in order to get your hands on AWS, you must have an AWS account. And the good news is we can sign up for free on AWS. So, what are the requirements and how we can sign up on AWS? We are going to learn a quick overview in this chapter today. So, let's get started, and make sure that you have subscribed DevOps Molvi. I really appreciate your support. So in this chapter, how to sign up on AWS for free, we will learn what is an AWS free account means. Creating an AWS account is free. So there are no charges to create an AWS account. And it gives you immediate access to the AWS free tier. Well, we successfully sign up on AWS, it means that we are going to enjoy the services for free for 1 year. Guys, in the previous chapter, we had a quick look on AWS free tier. We learned that there are services that are offered on a free trial basis. There are services that are free for 1 year, and there are services that are free for the rest of our life. So all those services are available immediately after we complete the sign up process. It means that after the sign up process is completed, we can immediately launch an AWS virtual machine, EC2 instance, or we can create a bucket, etc. The AWS free tier offers are available for 12 months after you create your account. I'm talking about the services that are free for 1 year. There are services that are always free. Okay. Now, that is our main concern. These are the questions that should pop up in your mind. That what are the requirements? What should I have for a successful free sign up on AWS? And the key requirements are an email address, abc@gmail.com, your personal email address or your organization email address. You can use it. Account name. We will use an account name. My account name is DevOps Molvi. So you can use any username as your account name. And the account password, you have to set an account password. Billing information. Now, this is actually a tricky part. Credit card or debit card. And if you don't have any credit card or debit card, we don't have to worry about it. I am going to tell you a secret here. I have got a great news for you. If you belong to Pakistan, then you can use your Naya Pay virtual card or Sada Pay virtual card. Okay. And if you are from India, you can use any fintech app like YonoV, Paytm, or Amazon Pay. The fact is that Amazon Web Services actually uses your credit card or debit card for $1 test transaction. Okay, $1 transaction is made, and after that, your sign up is complete. And now for AWS sign up, I have broken down all the necessary steps that we have to execute or we have to perform these steps. First of all, we have to visit this link, okay? And then click on create a free account, give the email address and username, verify the email address, set a strong password, add correct billing information, account creation confirmation from AWS. So these are actually the core steps to create a free AWS account. First of all, we can visit this link. We already did in our previous chapter while we were learning about AWS free tier. Then we can click on a create free account button. Here is a button. And then we can use the email address, username, verify the email address. Guys, my apologies since I have already a fully functional AWS account with $500 credits. So that's why I'm just going to share the process with you guys. I'm not going to sign up since I already have one account with $500 credits. And after that, I have included this slide that we have already gone through about AWS free tier. Now, I will click on this link and I will open it in. Okay, I will just copy it from here. And then after that, I will go to Firefox and actually I'm already logged in from my Chrome browser on my AWS account. Now you can see here we have this button, create a free account. I will click on it. And by the way, guys, just for your information, we have Naya Pay. Okay. And this application will work for you if you are from Pakistan, and you can use the virtual debit card of Naya Pay. Okay. We can sign up on Naya Pay, and then you can get your virtual debit card from the application. And similarly, we have another as Sadabe. Okay. And this Sadabe is also the best application that works, and you can actually use their virtual credit cards. Since I have tested on Azure as well. I can use NayaPay and Sadabe. Now these are active with my account. So you can use these applications. You have to download NayaPay or Sadape on your mobile. Okay. After that, you have to sign up on NayaPay, and you must have at least 400 rupees, an amount equivalent to $1. If you are from India, then you have to make sure that your app has actually an amount equivalent to $1, so that there are no issues while AWS performs a test transaction in which $1 is deducted and then it is returned back to your account. So if I search about payment apps in India, then okay, we have PhonePe, we have Paytm, MobiKwik. So I'm not sure, since I cannot give any reviews, but you can try any of these applications that are legit. Like Google says that in India, popular payment applications include Paytm, PhonePe, Google Pay, and PHIM. So you can try any of these payment applications, and I'm pretty sure that you are going to get a virtual debit card. Then you can use that debit card while you are signing up on AWS. But the point is, your application, your account number must have an amount equivalent to $1, since it is a $1 transaction. And I would recommend that you must have some extra rupees in your account to avoid any inconvenience. For instance, if you're from Pakistan, I would recommend that you must have at least 450 or 500 rupees in your application. And if you are from India, then I would recommend that you must have at least 150 rupees or 100 Indian rupees in your application to avoid any inconvenience while you are signing up on AWS. Then you can use that debit card number in the billing information on AWS. So now I'm on AWS console. Okay. For I will go back to make sure that you know how we can start from very beginning. I have clicked on AWS create a free account, aws.amazon.com/free. I have already given this URL here. Okay, you can copy it from here. And then I will click on create a free account, and it will redirect to AWS console sign up. Okay, and then I can use the email address here, root user email address. I will use my email address. Okay, and after that, DevOps Molvi EDC, and I will verify email address, security verification, 2XZBN4, and I will submit. Now verification code, I must have got a verification code here, and I will check it out. Okay guys, now you can see I have got this email from AWS, verify your email address. So I will copy the code and I will verify. Now you can see it's you. Your email address has been successfully verified. Now I have to set the root user. Your password provides you with sign-in access to AWS. So it's important we get it right. And now I will set the password here. Okay, and I will re-enter the password. So this would be our step 1 of 5. Okay, and the password has been set. Now AWS needs some more information from us. It is personal. I will click on the personal because I'm using for my own personal uses. And who should be contact about this account? I will write my own name, password Rahman, and I will just write the number and 1 2 3 4 5 6 7 8 9. Okay, and the country I will select as my country, and my address. This would be my address 1, and this would be my address line 2. Okay, so if you are writing your full address, you can write in these two address lines. And my city is Islamabad, and it is federal, and the postal code is yes. So I have read and agreed to the terms of AWS customer agreement, and I will continue to step number 2. All right, guys, now here is the billing information, which is the most concern and the last part in our AWS sign up. Okay, now I have to give the credit or debit card number here. Okay, and the expiration date of my card and CVV, the 3 digits that are back on your debit card, or you can see it on your application as well. Once I give all the billing information here, debit card number, its expiration date, and CVV, and the card holder's name, I will just click on verify, and AWS will perform $1 test transaction. And if your transaction is successful, your account would be created. And there might be any issues from your bank, from your application, which might be rejecting that transaction. So you have to contact that application, or you have to try any other cardholder or any other application. But the process would be the same when you are going to sign up. I have told you that first you need an email address, then email would be verified. Then you are going to give your location, your address, your phone number, your country, your city. And after that, the key part where most of the times some issues can happen because your application, payment application might be rejecting the transaction, or it is your bank that is rejecting your transaction. So you can try multiple applications. That's why I would recommend that you must use at least 2 applications. I had an issue with one of my banks, so I used an alternate bank account number to resolve this issue. And when I came to know that I can use SadaPay or NayaPay applications, here debit cards, and I didn't face any issues while using the debit card numbers of these applications. So in case of any issues, feel free to comment down, and I will try my best to help you out to get you a free AWS account. But these are the steps I'm not going to perform because I'm not going to use my card for multiple AWS account to avoid any inconvenience. But I have just guided you the process. This would be the process whenever you're going to sign up on AWS account. So after the billing information is confirmed and a test transaction is performed, you will get another email from AWS that your account has been created and it is now live and it is now fully functional. You can start creating your free resources on AWS. So that's it, guys. I hope that you know and you have learned how we can sign up on AWS for free. These are the steps that you have to perform. You must have an email address, okay, because AWS will verify your email address. You must have a phone number, you must have a valid address, and you must have a debit card, Visa, MasterCard, or American Express. And then you have to use your billing information while you are signing up. So once your test transaction is performed by AWS on your debit card, you will get a confirmation email address from AWS that your account has been confirmed. You have created an account on AWS. Now you can enjoy your free resources on AWS. So that's it, guys. But still, if you are facing any issues while signing up on AWS, feel free to comment down below and I will try my best to help you out. I will give you any other alternative that you can try for a free AWS account. In the next chapter, we are going to discuss EC2 on AWS. Make sure that you have subscribed DevOps Molvi. I will see you in the next chapter. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 4, and today we are going to discuss one of the most important AWS service, and it is EC2, Elastic Compute Cloud. Guys, in the previous chapter, we learned how we can sign up on AWS for free. But don't worry, we are going to learn practically how we can launch EC2 virtual machines, and we are going to connect with EC2 virtual machines in our next AWS Solutions Architect Associate course. But today, we are going to cover some general information about EC2, what is Elastic Compute Cloud, and what are the instance types, what is an instance family, which EC2 instance would be better or would be suitable for my workloads. So let's get started. And before we get started, make sure that you have subscribed DevOps Molvi. I really appreciate your support. So guys, first of all, what is EC2? EC2 stands for Elastic Compute Cloud. Elastic Compute Cloud. That's why ECC. There are 2 C's. So that's why it is known as EC2, Elastic Compute Cloud. And I'm saying this with my heart that this is one of the most common services in every IT organization. If any IT company is using AWS for its infrastructure, they must be using EC2 virtual machines for their dev, QA, sandbox, or prod environments. So EC2 was launched by AWS in 2006. So it means that this service is now 2 decades old. Okay, we are in 2025 and it's been almost 19 years, and this service is up and running for the first time along with S3. So we can say that EC2 and S3 are the pioneer services of AWS. Now, as we discussed in the previous chapter, that AWS has over 240 services, web services. There are 200 plus different AWS services, but AWS started its journey with EC2 and simple storage service. Amazon EC2 is a web service that provides resizable compute capacity in the cloud. EC2 instances are virtual machines, just like we launch virtual machines using VirtualBox or VMware Player. So we can say that EC2 instances are actually virtual machines running on AWS cloud infrastructure. Now, guys, here Amazon EC2 is a web service. You have to keep in mind that it is a web service. We can manage EC2 virtual machines from our web, from our browser, from Chrome, from our console. And it provides resizable compute capacity. Now, what does resizable mean? Resizable means that when I need more memory, I can upscale my virtual machine. And when I don't need that memory, I can downscale my virtual machine. Now, that's what resizable mean. There are multiple instance families. If I am launching my virtual machines like T2 Micro with 1 GB RAM and 1 CPU, and later on I decide to upscale my virtual machine to resize my virtual machine, then I can easily upscale. I can add additional memory resources, and I can add additional vCPUs, virtual CPUs. I can attach storage with my EC2 virtual machine. Now that's what resizable compute capacity means. Resizable when I need more resources, more compute resources. From compute resources, I mean to say memory, CPU, storage, elastic IP addresses, and so on. So, when I need more resources, more compute resources, I can easily get them and I can resize, upscale my virtual machine. But when I don't need those resources, I can downscale, I can get my virtual machine back to T2 micro with minimum amount of resources, or downscale my virtual machine. This is known as resizable compute capacity. It is elastic. You can expand it and you can shrink it. Okay, so that's the beauty of cloud. That's the beauty of EC2, and it provides resizable compute capacity. We can also get EC2 instances on demand, paying only for what we use. Guys, in the previous chapter, we have already discussed about pay-as-you-go model, which means that pay for the resources that we use. We should pay only for the resources that we are using. If I want to run a virtual machine for one day, I can spin up a virtual machine, and after using the virtual machine, I can easily terminate it. So I have to pay for the usage of one day only, not for the whole month. Okay, so that's what pay as you go mean. Pay for the resources that you use, and we can launch on demand instances. There are, by the way, different types of EC2 instances that we are going to discuss. So we can launch on demand EC2 instances whenever we need. It is one of the most frequently used AWS services in the world. Okay, one of the biggest virtual machines services in the world, I would say. EC2's scalability and flexibility make it a popular choice for businesses of all sizes. Whether it is a software house with 3 or 4 DevOps engineers and developers, AWS will fulfill all their infrastructure needs. And when we are talking about a very large IT organization, just like Uber or Netflix, they are also running on AWS with huge compute capacity. So AWS fulfills the demands, the IT infrastructure needs of companies of any size. Still worried about the infrastructure costs? Are you worried? AWS has already bought the servers, which means that the servers are already mounted and running in AWS regions and availability zones. Rack and stack them, and they are already online, ready to be used by people like us. We don't have to worry about purchasing any type of hardware upfront. AWS is constantly operating a massive amount of compute capacity, and we can use whatever portion of that capacity when we need it. Guys, back in 2010 or 2005, almost 20 years ago, when we are going to launch our product, our application, we had to buy the servers, we had to buy the infrastructure, and then we have to mount those servers in our physical data centers, in our racks, and we have to pay upfront costs for that infrastructure. But now it is super duper easy to launch our application. We just have to create an AWS account, which I told you that it is absolutely free and easy. We can run our applications on AWS resources using free trial or using free tier. Okay, and then if our application is running smoothly on AWS, then we can buy more AWS resources. Then after that, using those resources, we are going to pay for what we have used. So it means that there are no infrastructure costs, upfront infrastructure costs that we have to put up. that we have to invest. Okay, I don't have to put even $1 as upfront cost for infrastructure, for my infrastructure. Okay, that's the beauty of AWS. So if you're planning to run your applications on AWS, you don't have to worry about any upfront infrastructure costs. Now guys, this is beautiful. My virtual machine is a few clicks away. I have to launch my virtual machine using AWS CLI or AWS console, and I can connect with my virtual machine using username and password, and also I can use SSH key, private and public key pair, and then my virtual machine would be ready to be used. I can run my code, I can deploy my application on that virtual machine in few clicks. All right guys, now from the exam perspective, it is important to know Amazon EC2 instance types. You are going to be asked in the AWS Cloud Practitioner certification exam, and you have to tell the most suitable instance type for the workload. So for that purpose, we must know the types of EC2 instances. We need an ideal EC2 instance all the time meeting our workload requirements. Which virtual machine would be best for our workload? Which machine would be ideal if I want to have storage? Which machine would be ideal if I want more and more memory resources? So we have instance types, and we have to know which is the most suitable instance type according to my workload demands. Each instance type is grouped under an instance family and are optimized for certain types of tasks. EC2 instance types give us the flexibility to choose the most suitable virtual machine with appropriate resources like CPU, RAM, and storage. Just like I told you guys that if I want to have more memory resources, for instance, it is the demand of my application to have more memory, then I must choose the most suitable virtual machine. I must choose memory optimized virtual machine. If my demand is storage, I want to have terabytes of storage, then I must choose storage optimized virtual instance. If my application is any mathematical application and it needs more compute resources, then I must go with compute optimized virtual machines. So the good news is that EC2 comes along with every kind of instance types under instance families. Instance families can be memory optimized, GPU optimized, CPU optimized, and storage optimized. So let's discuss them one by one. EC2 instance types, general purpose instances, provide a good balance of compute, memory, and networking resources. And then we have compute optimized instances, which are ideal for compute intensive tasks like gaming servers, high performance computing. And we have memory optimized instances, which are good for memory intensive tasks. And most of the times in our demonstrations and in our upcoming labs, we are going to use general purpose instances, which are balanced and have a sufficient amount and equal amount of memory and CPU and storage. So general purpose instances are more liked and more used in IT companies because they are balanced with CPU and memory and storage. Okay, so we are also going to use general purpose for most of our labs, and but we must know about the instance type. Like this diagram is showing the instance of our choice. For instance, if I have general purpose, I have compute optimized, memory, accelerated computing, and now you can see the instance types, and there is more information about each instance. Like in this instance, T2.nano, we are getting one CPU. We are going to get CPU credits per hour, 3 CPU credits per hour. We are going to get only half GB RAM. So most of the times we are going to launch this T2 Micro, and this virtual machine is available on free tier. We can also launch big virtual machines using T2 large with 2 CPUs and 8 GB RAM with 36 CPU credits per hour. And you can see we have network performance. Now, this virtual machine has very low network performance. Now, EBS means Elastic Block Store. We are going to discuss it in our simple storage service, AWS Storage service. And you can also see the other virtual machines have low to moderate network performance. So these virtual machines are recommended for dev or QA environments, not recommended for prod because they have very low to moderate performance, not with high performance. But these are the instance types. We have general purpose, we have compute optimized, memory, storage, and accelerated computing. So now guys, we are going to talk about EC2 pricing. Amazon EC2 offers a variety of pricing options for different use cases. With Amazon EC2, we pay only for the compute time that we use. The default Amazon pricing model is pay as you go. Okay, but there are different other types of EC2 pricing, and we have multiple different types of EC2 instances that we can use to reduce our infrastructure costs as much as possible. Now, we have different choices. What are those choices? Let's discuss them as well. The first is on demand. On demand is the most common type of EC2 pricing. And in on demand instances, which is ideal for short term, irregular workloads that cannot be interrupted. No upfront costs or minimum contracts apply. Most of the time, guys, we are going to use on-demand instances. On-demand means that whenever you want to run an EC2 instance, you can just hop on AWS console and launch your virtual machine. When you don't want to use it, you can terminate it. This is the most common model. And it works on pay as you go. Okay, so we have to pay for the resources that we use. So these are on demand instances. These instances run continuously until you stop them. Okay, the instance will run for years until and unless I stop it, until and unless I terminate it. And I have to pay for the compute time that I am using. Okay, so if I am running an instance for 2 or 3 years without stopping it, so it means that I have to pay for that time. And this is the most common way of launching EC2 instances. We are going to get started with EC2 labs using on-demand type of instances. So on-demand instances are ideal for dev and sandbox environments, but I would add here that they're also best for production environments as well. So we can run on-demand instances, we can stop them anytime you want, we can terminate them, and also guys, we have to pay for the resources, we have to pay for the instances only for the time we have used them on pay-as-you-go model. Now, what is a reserved instance? As the name says, we are going to reserve the compute capacity for a long time commitment. That time commitment can be 1 to 3 years. These are suited for steady state workloads or ones with predictable usage and offer you up to a 75% discount. If I am going to commit, uh, just like here, you qualify for a discount once you commit to a 1 or 3 year term and can pay for them. If I am going to make a commitment that this is my virtual machine and I am going to use it for 3 years, okay? So I am committing with AWS that I am going to use this virtual machine for 3 years. So I am going to reserve it. When I am going to reserve a virtual machine for that time, for that period of time, then I will definitely get a discount of 75%. So I can reduce my infrastructure cost. If I'm going to commit that I'm going to use that virtual machine for 1 year or maximum of 3 years. So because of that commitment, AWS gives us a discount, and we are going to reduce our infrastructure costs if we are going to use the reserved instances. So it is a better decision that if I am going to use a virtual machine for 3 years, then I must choose reserved instances instead of on demand, because in reserved instances, I'm going to get a huge 75% discount. So the next is EC2 instance savings plans. And this is just like reserved instances. EC2 instance saving plans reduce your EC2 instance costs when you make an hourly spend commitment to an instance family and region for 1 year or 3 year term. So it is almost the same as reserved instance. We are going to have a commitment for at least 1 or 3 years for a specific instance family and a region. So if we are going to commit, then we are going to get a discount from EC2 under EC2 instance savings plans. And after that, guys, we have spot instances. Spot instances are ideal for workloads with flexible start and end times, or that can withstand interruptions. Spot instances use unused Amazon EC2 computing capacity and offer you cost savings at up to 90% of on-demand prices. So that much discount we are going to get on spot instances. But remember, spot instances are the unused compute capacity of AWS. You have to claim it. Once you claim it, you get it. But now it is not your choice to stop or terminate the instance. So if AWS needs the compute capacity back, they are going to terminate our spot instance. So that's why I have written that these instances have to withstand interruptions. They can be interrupted, they can be stopped or terminated anytime by AWS. Since this is actually the unused compute capacity of AWS, and I can get it on 90% discount, but when AWS needs the compute capacity back, they are going to stop or terminate my instances. So it is important to understand that we have to launch those virtual machines that can withstand interruptions, that can be stopped anytime, that can be terminated anytime. So we have dedicated hosts, just like we can get dedicated servers. If I want to have a dedicated server, I can use dedicated hosts. Dedicated hosts are physical servers with Amazon EC2 instance capacity that is fully dedicated to your use. Just like we get dedicated servers from data centers or other web hosting companies, we can get dedicated servers from AWS as well using dedicated hosts. Now you must have an idea about on-demand instances. We have also discussed reserved instances, savings plans, spot instances, and dedicated instances. So these are different types of instances that are available with different types of discounts that we can avail. And after that, guys, we have AWS EC2 auto scaling. Now, first of all, we have to understand scalability, or what is scaling. Scalability means a system's ability to handle increasing workloads and demands while maintaining performance and reliability. It's about how can easily a system can grow or shrink. Now, this is actually the definition of scaling. A system that can grow or shrink to meet changing needs without performance degradation. The AWS service that provides this functionality for Amazon EC2 instances is Amazon EC2 auto scaling. For instance, guys, let me explain this with an example. For instance, if I am running an e-commerce store and I know that my store gets traffic from 6 p.m. to 10 p.m. every evening, the resources in my infrastructure should be increased automatically. And when the traffic is reduced and back to normal, then my EC2 infrastructure should be terminated automatically. This is actually auto scaling. With the increasing amount of traffic, my EC2 resources should grow. More EC2 instances should be added automatically. And when the traffic comes back to normal, the extra resources should be deleted or terminated. So I don't have to pay for them as well. Now, there should be a question in your mind that how we can implement auto scaling. We can use CPU threshold. For instance, if the CPU on my EC2 virtual machine crosses the threshold of 80%, then I should have more virtual machines launched automatically. And when my CPU threshold is back to 60% or less than 80%, then the extra virtual machines should be terminated. So that's how auto scaling works. Auto scaling means with the increasing demand of resources, more resources are added to the pool. And with the decreasing workload, the extra resources should be terminated automatically. This is what auto scaling means. And Amazon EC2 scaling enables you to automatically add or remove EC2 instances. I have already explained it in response to changing application demand. Okay, with the increasing demand of our application, the resources should be added. With the decreasing amount of traffic on our application, the extra resources should be terminated. This is auto scaling. Now we have two types. I will quickly go through these types. Dynamic scaling, which responds to changing demand, and predictive scaling automatically schedules the right number of Amazon EC2 instances based on predictive demand. Now, from predictive demand, I have explained or given you the example of the time frame from 6 p.m. to 10 p.m. Now, it is a prediction. I know that my application gets more traffic, more users in that time frame. So it is predictive scaling. And we can use dynamic scaling using CPU or memory threshold, that whenever the CPU or memory resources cross 80% or 90%, more resources are added to the pool. This is actually the example of dynamic scaling. And in predictive scaling, I can launch more virtual machines in any given time frame, that I know that my application gets more users, more traffic, more load in that time frame. Now, this is the example of predictive scaling. So we have two types: dynamic, that changes dynamically; predictive, that I know the time frame in which my application gets more workload. So these are two types of auto scaling: dynamic and predictive. Dynamic scaling responds to the changing demand. Predictive scaling automatically schedules the right number of Amazon EC2 based on the predictive demand. So you have to know when your application gets more users, then you can predict. But if you want to use dynamic scaling, you just have to set the CPU or memory threshold, that whenever my application crosses that threshold, more resources are added. Okay, I hope that you understand now. Now, guys, you can see in this diagram, we have auto scaling group. We are going to create an auto scaling group in our lab, in our solutions architect course. You can see this is the minimum number of instances. It means that one instance will always run. And if my application gets more traffic, more users, then one EC2 instance should be added. And this is actually the desired scenario. And maximum number of instances are 4. You can see. So my auto scaling group will expand, will grow up to 4 EC2 instances, and this would be maximum Amazon EC2 instances that my auto scaling group will have. So it means that if these two instances are also occupied with the increasing amount of workload, there would be more 2 EC2 instances that would be launched using this auto scaling group. So it means that my auto scaling group will have 1 minimum EC2 instances and 4 maximum EC2 instances. So that's how autoscaling groups work. We can define the minimum number of EC2 instances and the maximum number of EC2 instances. With the increasing amount of traffic and load on our application, these instances will be launched automatically within that autoscaling group. Now, guys, whenever we are talking about autoscaling, we have to remember load balancing as well. If I go back to this diagram again, you can see that we have four EC2 instances. Now, I want that each one of them should get equal amount of traffic. Now, how is it possible? It is possible with load balancing, so that each instance should get equal amount of workload, equal amount of users or traffic. So it is possible using elastic load balancing. Elastic load balancing automatically distributes incoming application traffic to multiple EC2 instances. The traffic is equally distributed among the EC2 instances to avoid a single EC2 instance getting overwhelmed. So elastic load balancing makes sure that each EC2 instance should get equal amount of traffic, equal amount of load. Elastic load balancing avoids that one EC2 instance should get more workload and the rest of the three EC2 instances in an autoscaling group should get less amount of workload. No, elastic load balancer makes sure that every EC2 instance in a given autoscaling group should get equal amount of traffic. A load balancer is placed on top of autoscaling group. The incoming traffic routes to the load balancer first. So it is load balancer that gets the traffic, and then load balancer distributes the traffic on the EC2 instances equally. The load balancer equally distributes the workloads among instances. So this is super easy phenomena about elastic load balancer, and the core purpose of elastic load balancing is to distribute equivalent amount of traffic, just as I have told you in this diagram. Now you can see there are two users and we have elastic load balancer on top of autoscaling group. So we have users, we have load balancer, which is placed on top of autoscaling group. So when users are going to access our application or use our application, elastic load balancer will make sure that equal amount of traffic should be routed on these EC2 instances. Now in high demand period, you can see the users have been increased and all the users are accessing my application. So the elastic load balancer will get the traffic first, okay, because it is placed on top of the autoscaling group. Now elastic load balancer will make sure that there are equivalent amount of users. For instance, if I have 4 EC2 instances in the autoscaling group and I have 800 users, then elastic load balancer will make sure that each EC2 instance should have 200 users at one time. So let me repeat it again. This is my application running on an autoscaling group. I have 4 instances in that autoscaling group and I have placed elastic load balancer on top of the autoscaling group. The users are going to access my application. For instance, if my application is getting 800 concurrent users, then elastic load balancer will make sure that each EC2 instance should be getting 200 concurrent users on each one of them. So to avoid single instance getting overwhelmed, this is actually the responsibility of elastic load balancer. It will make sure that every EC2 instance in that autoscaling group should get equivalent amount of workload. I hope that it is now super clear, and this concept is literally so easy, and we are going to implement elastic load balancing in our solutions architect course. After that, guys, now winding up the lecture, we have other compute services as well, Like we have Elastic Container Service, we have Elastic Kubernetes Service, and we have also Lambda, which is serverless compute. So these are all compute services that are offered by AWS. And now it's lab time, and after that we are going to discuss about infrastructure, AWS infrastructure. But now in lab we are going to see the EC2 instance types. As you can see, I am going to search for EC2 instance types, and now if I open this as Amazon EC2 T3 instances, I will open this as well. And first of all, now we can see Amazon EC2 instance types. So if you want to explore more about the instance types, you can just search for EC2 instance types in Google. And now there are hundreds of EC2 instances with different amount of resources. Now, for instance, if I go to general purpose and uh, T2, okay, this would be the most common instance family that we are going to use. Just like I told you, T2 Nano, T2 Micro, T2 Small, T2 Medium, and we have T2 Large, T2.X Large. Okay, now if I want to see memory optimized, now there would be more memory offered in these instances. Now you can see the amount of memory. The minimum is R8G.medium with 8 GB of memory. And wow, now you can see we have 1536 GB of RAM. So these are all memory optimized instances. We are going to get terabytes of RAM in these instances. Similarly, if I want to see the storage optimized, then we are going to get terabytes of storage. You can see the minimum instance is offering 468 GB of storage. And after that, if I scroll down, you can see the amount of data storage, 22,500 GB of storage in this instance that I will get. So if you are looking for storage optimized instances, we have the storage optimized here. Similarly, we have compute optimized, and you can see we are going to get more vCPUs in this type of instance family, 192 CPUs. So just like I told you in the very beginning that AWS is one-stop shop. You are going to get the instance of your choice in Amazon EC2. EC2 has over 800 plus different types of instances that are suitable for our needs. So any kind of instance that I'm looking for, I will definitely going to get it. If I am going to get the EC2 instance with minimum resources, I can get started with T2 Micro or T2 Nano. And if I am going to get the super large and the heaviest instances, I am going to get them as well. And also guys, if I want to have more memory, I can move with memory optimized instance. I want to have more compute capacity. I have the choice of compute optimized. I want to have more storage. Then I can get started with storage optimized instances. You can see that there are other types of instances as well. HPC, high performance computing. Now these would be super expensive instances. And now you can see we have 64 CPUs, 128 GB of memory, and these are super high performance computing. And I can get more ideas by clicking here on the instance families. You can see Amazon EC2 HPC 6A instances are optimized for tightly coupled compute intensive high performance computing workloads. So each instance family and each instance type is perfectly explained, and all the features of that instance type or instance family are mentioned here. Now, if I want to explore each instance family separately, I can go through all the details. Like I have opened Amazon EC2 T3 instances. Now, these are low cost, general purpose Amazon EC2 instances, and I can have more details about the instance types here, the CPUs, memory, and more details are mentioned on these instance types. So that's it, guys, for today's lecture. I hope that you have a clear picture of EC2. EC2 is one of the most common AWS services in the world. Every IT company uses EC2 virtual machines to run their workloads, and there are questions that are asked in the AWS Cloud Practitioner certification about the most suitable EC2 instance for the given workload. So, in case of any questions, feel free to ask in the comment section. I will see you in our next lecture, AWS Infrastructure. Make sure to subscribe DevOps Molvi. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 5, in which we are going to discuss about AWS infrastructure. Guys, we know that AWS is the world's largest cloud platform till date. AWS has the world's largest market share if we talk about the cloud platforms. AWS is the world number one cloud platform. And the reason behind is AWS Global Infrastructure. We know that AWS has expanded its regions, availability zones, edge locations, data centers around the world. That is why AWS uses powerful and robust infrastructure to power all of its services. So that would be a little quick chapter in which we have a quick look over the AWS infrastructure. So let's get started. And before we get started, make sure that you have subscribed DevOps Molvi. I really appreciate your support. So guys, we know that AWS is global. What does this mean? The AWS spans 114 availability zones within 36 geographic regions. Now, I'm recording my video today. It's 15th of July 2025. And it does not mean that AWS expansion of its regions has stopped. No, there would be still one region coming soon, and there are multiple locations where AWS is going to build new regions, new availability zones, and data centers. But till date, AWS has 114 availability zones. Now, what is availability zone? We are going to discuss it in the next slide. And 36 geographic regions, 16 more availability zones, and 5 more regions in New Zealand, the Kingdom of Saudi Arabia, Taiwan, Chile are coming soon. So these are the geographic locations in which AWS is planning or building its regions. AWS is building its data centers on these 5 upcoming locations. So that would be roughly 41 geographic regions that AWS will have in the coming year. So till date, AWS has 114 availability zones and 36 geographic locations or geographic regions. Now we are going to discuss each term one by one. So what is an AWS region? We talked about 36 AWS regions. So what is actually a region? An AWS region is a physical location on Earth where AWS has its data centers. For instance, if I belong to Pakistan and AWS decides to build an AWS region in one of the Pakistani cities like in Karachi or Lahore or in Islamabad. So it means that either Karachi, Lahore, or Islamabad is AWS geographic location. It would be an AWS region. Like we have Mumbai in India, we have London, we have Sao Paulo, we have US East, we have US West. These are all geographic locations where AWS has built its regions. AWS regions are distinct geographic areas like US East, North Virginia, US West, Oregon, Europe, Ireland, etc. So these are all AWS region, and each region can have multiple availability zones, and each availability zone can have multiple data centers. I hope you got my point. So among these AWS regions, the North Virginia or US East is the world's largest and most mature AWS region. And AWS has already launched 36 regions worldwide. Number 37 is coming soon as per AWS website. And it would be going to be launched really soon. So there would be 37 regions in total. But as per previous slide, we can know that AWS is going to launch more regions in New Zealand, Saudi Arabia, Taiwan, Chile. So there would be total of 41 AWS regions in the future. Now, what is an availability zone? We know that geographically, a location having availability zones or data centers is known as a region. That region is actually a geographic location. Now, in that region, there can be one availability zone or multiple availability zones. Now, what is an availability zone? An availability zone is a collection of one or more data centers. Now, focus on this point that one availability zone can have only one data center, or it can have one, two, or three data centers as well. So, it is not limited that one availability zone should have only one data center. No, a single availability zone can have one, two, or three data centers. So an availability zone is a collection of one or more data centers. Now, what is a data center? Actually, a data center is where our actual servers are mounted. They are mounted in the racks. There are generators. That data center has a wall, a building where thousands of servers are running, and one availability zone can have this one data center or two or three data centers. Availability zones are highly available data centers within each AWS region. Each AZ availability zone is a physically isolated yet connected cluster of one or more data centers within a specific AWS region. Guys, for instance, if I am going to launch a virtual machine, I have the choice that I want to launch it in US East region. Then I have the choice that if I want to launch it in availability zone A1, B1, C1, or F1. Okay, it is my choice that I want to launch the AWS EC2 instance in any region of my choice or in any availability zone of my choice. So each availability zone is a physically isolated yet connected cluster of one or more data centers within a specific AWS region. Now, it concludes that each AWS region can have one or more availability zone, and then each availability zone can have one or more data centers. So it means that an AWS region consists of multiple availability zones with multiple data centers. By deploying applications across multiple AZs, we can achieve high availability. Now, what is the core purpose of having too many data centers or too many availability zones in a single region? For instance, if any unfortunate incident happens and one of the availability zones goes down, then all the traffic is diverted to the availability zones that are up and running. Now, that is actually for customers so that their applications, so that their data never goes down. Now, this is high availability. If any of the data centers in any availability zone goes or faces power outage or internet outage, but at the end of the day, the customers won't face any downtime. because their applications and their data would be made available with the help of other data centers or availability zones that are up and running. Now, this is high availability. At the end, customers will never face any downtime. Their applications or data will never go down. And that is actually the core purpose of having a cluster of availability zone in one AWS region. A few days back, I was just going through a blog and on LinkedIn, and the guy told us that the region US East 1, which is the world's largest AWS region, consists of 6 availability zones. Okay, now each availability zone, let's say it has 3 data centers, then it means that the world's largest AWS region, US East 1, maybe consists of 15 to 18 data centers. This one largest AWS region, US East 1, may consist up to 15 to 20 data centers or availability zones. Now, this is actually the graphical representation of regions and availability zone. As we know that one single AWS region can have multiple availability zones, right? I hope that you know it. Now, we have these yellow dots as regions. I have North California region, I have Oregon region, and I have US West Go Cloud region. Now, each region consists of 4 or 3 dots, blue dots. Now, each dot represents an availability zone. Now, you can see the Oregon region has 4 availability zones. Okay. Now, similarly, the Gov Cloud US West has 3 availability zones, and similarly, North California has 3 availability zones. Now, each geographical location like Oregon or North California or US West can have multiple availability zones, and each yellow dot is a separate physical or geographical location, and it represents an AWS region. So similarly, if we go through the world's map, then we are able to find AWS regions. I will show them to you later. And now we can see each AWS region can have multiple availability zones. Each region is represented with a yellow dot, and each availability zone is represented with a blue dot. Alright guys, now what is an AWS Edge location? AWS Edge location is also a data center with the core purpose of serving our content. I want to access my content. I want to have my content accessible as quickly as possible. I want to access my data as quickly as possible. Now, if I am from Pakistan and my virtual machine or my data is in US East 1, then it definitely means that if I'm going to access that data with that amount of distance, then there would be latency. If I am facing delays, then it definitely means that there is high latency. But to avoid high latency, AWS has built edge locations. These are data centers with one core purpose: to serve the content to the customers with minimum delays, with minimum latency. So that is known as edge location. So maybe I am accessing my data from the nearest data center, like from Mumbai or in Asia. So that would avoid the delay, that would avoid the latency, and I will access my data, I will access my applications with minimal latency. And AWS edge locations are primarily used by Amazon CloudFront. The service that covers all the edge locations is known as Amazon CloudFront. And AWS CloudFront is used to deliver content to the users with minimum latency. Guys, latency means the delay. Okay, delay to access your data, delay to access your application. And the core purpose of AWS CloudFront is to remove the delays, to get rid of the delays, and to reduce the latency so that the content is accessible to the users with high speeds. Okay, it also ensures that faster content delivery with the cached copy of the content is possible. So the users will access their content with faster speeds, and that is the purpose of AWS edge locations. Edge locations are built around the world by AWS. Now these edge locations are actually known as the point of presence. CloudFront points of presence. Edge locations are known as CloudFront points of presence. AWS CloudFront has over 700 plus points of presence in 90 cities and across 47 different countries. And the core purpose is to serve the cached copy of content so that the users never face delays, the users never face latency. All right, guys, it's lab time, and we are going to see the AWS regions here. Regions. And now we can see the global infrastructure, regions, and availability zones. If I open it, and I will have a clear picture of AWS regions and availability zones. Now that actually website or that portal will have the latest information about AWS regions and availability zones. Now you can see the AWS cloud spans 117 availability zones. I have told you 114, but 3 availability zones are still in progress within 37 geographic regions with announced plans for 13 more availability zones. Okay, these are actually announced, and it means that there are 4 AWS regions that are coming soon on the global map, North America, and it has Gulf Cloud, US East, it has Canada Central, Canada West, Mexico Central, and it is North America. And we have also edge locations here. Now you can see there are actually 31 availability zones. The AWS cloud in North America has 31 availability zones, and there would be definitely more data centers within 9 geographic regions and 31 edge network locations and 3 edge cache locations. Now you can see all the locations are mentioned here. The edge cache locations actually have our cached copy of the content. That's why these are known as edge cache locations. Now these are regions. AWS has the concept of a region, which is a physical location around the world where we cluster data centers. So it means that one region can have multiple data centers, availability zones, and we can explore more about AWS regions. If I navigate to South America, you can see the map changes. Now, this is actually South America, and it has 2 geographic regions, Sao Paulo and Chile, which is coming soon. You can see South America, Chile. As I told you that it is coming soon, and in Europe, Ireland would be coming soon. And it has 31 edge locations and 9 geographic regions. If I check Asia Pacific, which is near to me, okay, and I have Hong Kong, Asia Pacific, Hyderabad, India, Jakarta, Malaysia, Mumbai. So there are actually 13 geographic regions and 23 edge locations. Lastly, Australia and New Zealand. New Zealand is coming soon. Now you can see here, New Zealand is actually coming soon with 3 availability zones. But you can see Australia, Sydney was launched in 2012 with 3 availability zones. And if I click on AWS Global Infrastructure, we can see here the most extensive global cloud infrastructure with 37 launched regions, 117 availability zones. And these are the actual benefits of having multiple regions, edge locations for availability, performance, scalability, and flexibility. So that's it for today, guys. We have discussed about AWS Global Infrastructure. about AWS regions, availability zones, data centers, and edge locations. In the next chapter, we are going to talk about AWS networking. Make sure that you have subscribed DevOps Molvi. Stay tuned, and I will watch you in the next chapter of AWS networking. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 6 of our AWS Cloud Practitioner certification. And today we are going to cover the most important concepts of AWS services, and it's about AWS networking, how networking works in AWS. We know that in traditional networking, while we were reading this subject in our graduation, we had this subject, right? Networking concepts. And we saw that in our university labs, there were 20 or 30 or 40 computers that were interconnected with each other. And while the computers on the same network, then we can easily share the data, we can easily share the files and resources when all of those computers are on the same network, right? I hope that you remember. So, in AWS, how networking works, by the way, let me tell you quickly that AWS works the same way as our physical networking. But how and what are the services that are involved in AWS networking? We are going to have a quick look on those services, and these services are also important from the exam perspective, from the exam point of view, because you are going to be asked about AWS networking, VPC, subnets, network access control lists, etc. So, without any delays, let's get started and make sure that you have subscribed DevOps Molvi. I really need and appreciate your support. So, first of all, guys, what is networking? I have already given you the example of traditional networking or physical networking that we saw with our eyes in our labs. And also, if you're working in any IT company or in any software house, you can see that there are hundreds of computers, there are hundreds of systems that are connected with each other through wires or LAN or Wi-Fi, right? Now, this is how networking works. When all the computers are on the same network, then it means that each computer can be accessed from any other computer. For instance, if there are 10 computers, then I can easily access all those computers from my computer if we are on the same network, and I can easily share the data. I can easily transfer the data among different computers if they are on the same network. So, that is actually what networking means. Networking means interconnected computers that can exchange data and share resources with each other without any blocker, without any issues, without any restrictions, because they are on the same network. In AWS, networking is the process of connecting cloud-based resources so that they can communicate securely. I told you about physical computers, right? Now change this to EC2 virtual machines. Where there were physical computers, now we have EC2. We have virtual machines that are on the same network. And guys, when we have all those virtual machines on one network, on the same network, it means that all those virtual machines can talk to each other. We can access them without any issues because they are on the same virtual network. Now, what is virtual network and what it is known in AWS? It is known as virtual private cloud. Our next slide. Yes, what is AWS VPC? VPC stands for virtual private cloud. Okay, this is one of the biggest component of AWS networking. You are going to build a VPC, and then using that VPC, you are going to build the infrastructure and resources within that virtual private cloud. So it means that VPC is the core requirement of building resources, building infrastructure on AWS. And without VPC, it is not possible that our resources can talk to each other or can communicate. So therefore, VPC is the building block of AWS infrastructure. Virtual private cloud is logically isolated network where we launch our resources. So it means that it is logically or virtually an a separate network, my own network. This is my space. So this is my network. If I am creating using my AWS account, so it means that that network is limited to me or my account, and any other people or other different AWS accounts cannot access the resources that I am going to build within my virtual private cloud. So it is isolated. It is a separate uh, networking space where I can build, where I can run my resources. From resources, I mean Elastic Compute Cloud EC2 virtual machines, Elastic Kubernetes clusters, containers within that virtual private cloud. It's like having your own private network within AWS. So it is my own space. It is my own network on AWS if I am going to create a virtual private cloud on AWS. It means that this would be limited to my user or my account only. No one can access it. No other AWS account or AWS user can access it. AWS VPC is a service used to establish boundaries around our AWS resources. So this is actually a wall, a virtual wall, you can say, a virtual boundary. Within that boundary, I am going to create virtual machines, buckets, storage, etc. Whatever I want. So this is actually virtual private cloud, and that's not the end. It is continued. In a VPC, we have a complete control over the VPC's networking configuration, including IP address ranges, subnets, route tables, and network gateways. Everything is modifiable. That's what I mean to say. We can modify, we can have the subnet range of my own choice. We can have the public subnet, we can have this private subnet ranges, and I can modify, I can configure route tables and network gateways using that VPC. I can remove, I can add more in that virtual private cloud because it is my own space. I can do whatever I want. Whenever we create an account on AWS, a default VPC will be created for us. That is actually a created VPC by default by AWS. So when I create an account on AWS, you are going to see one default VPC. We can use that default VPC to build our resources, and that would be a private space as well. But it would be better for us to learn about VPC. We should create a new, our own virtual private cloud with our own subnet ranges, with our own route tables and network gateways. But we have a default VPC and we can build our resources within that default VPC that is created whenever we create an account on AWS. So guys, what are the core components of virtual private cloud? We are going to cover almost all the important components of VPC. Number one is subnets, security groups, internet gateway, virtual private gateway, access control lists, NAT gateway, and VPC puree. Now let's discuss all of these components one by one because we are going to get the questions related to these AWS components in Cloud Practitioner certification. So first of all, what is a subnet? This is actually the core component of VPC. A subnet is a range of IP addresses in our VPC. Guys, my fellows, I try my best to present the most simplest definition for you because I want you to understand quickly as possible. So that's why I try to write the most simplest definition of the most a difficult or tough concept. Therefore, I want you to understand it quickly that a subnet is a range of IP addresses. So it means that from one IP address 10.0.0.1 to 10.0.0.255. Now, this is actually a subnet range, a full subnet range of 256 IP addresses. So it is collectively known as a subnet. And that is actually a private subnet. And that's how we can have a public subnet. Now, there is a difference between a private and a public subnet. As the name says, private subnet is for our own private usage, and a public subnet with public IP addresses that are exposed to internet for our external users, right? You got the difference? Private subnets and public subnets. And also I have explained both subnets here, but subnets are further used in a VPC to divide the space. How the space is divided? We have public, we have private. Now, first of all, public subnets contain resources that need to be accessible by the public, such as an online store's websites. For instance, if I have an e-commerce store, it is obvious that I want my users to access these e-commerce stores on their web browser. So I will need a public IP address. And for that public IP address, I will need a public subnet. And similarly, guys, in private subnets, which contain resources that should be accessible only through our private network, such as a database. Since I don't want my users to access my data, I don't want my external users to see my data. Therefore, it is a recommended practice to have our database in our private subnet. For public subnets, those applications should be in the public subnets that are exposed to the internet, that I want my users to access, okay? Like my website or my e-commerce store, and where I'm storing my data and sensitive information, secrets, etc. I want all of that information within my private subnet. So I have given both examples of a public subnet like an EC2 virtual machine with a public IP address, and for private database, a database that contains my data and it is only accessible to me, okay? Because it is my private property. I don't want to expose my data, my database to other users over the internet. Therefore, I must be using a private subnet. So that's how subnet works. A subnet is actually an IP address range. We have public subnets and we have private subnets. Those applications or those resources that I want to expose publicly, I should have those resources within the public subnet. And for those resources that I don't want to expose to the public, I should build all those resources within a private subnet. So I have given the examples of both. I hope that this concept is clear, but it is still continued. In a VPC, subnets can communicate with each other. Okay. So if I have 2 or 3 private subnets, it means that within that VPC, all those subnets can talk to each other. For example, an application that involves Amazon EC2 instances in a public subnet communicating with databases that are located in a private subnet. We must understand about this because actually it is a really important concept, because in a VPC, we can have public and private subnets at one time. So in order to make my application fully functional, it is a must and it is compulsory that the resources, whether they are in public subnet or in private subnet, they should talk to each other. They should communicate with each other. And guys, luckily in a VPC, it is possible that public subnet can talk to the private subnet. And similarly, a private subnet can communicate with the public subnet. So it means that the resources that are built within a public or private subnet in a single VPC, they can easily communicate with each other. That's how it is possible that EC2 virtual machines in a public subnet can communicate with a database in a private subnet because they are in one isolated virtual network, which is known as a VPC. So we can have public and private subnets in a single VPC. Those subnets can communicate with each other, and this simple example will clear your concepts. You can see here public versus private subnets in a single VPC. On my AWS account, I have two subnets. This is public subnet, which is running EC2 instances, and this is my private subnet, which is running databases. But since all these resources are created within a single VPC, regardless of the fact that it is a public and it is a private subnet, since they are in the same VPC, it is possible that the EC2 virtual machines from this public subnet can communicate with the databases from this private subnet. So that is actually the beauty of virtual private cloud. VPC makes it possible that the resources in a public subnet or in a private subnet can talk to each other. They can communicate with each other to exchange the data, to exchange the information, to share the data. Okay. Now, guys, what is a security group? The simplest definition of a security group is a virtual firewall. Okay. A virtual firewall that controls inbound and outbound traffic for an Amazon EC2 instance. So if I want to have a virtual firewall on EC2 level, then I can create security groups. I can allow certain ports, and I can disallow or deny any type of port. By default, a security group denies all inbound traffic and allows all outbound traffic. So in a default VPC, now it is obvious that every incoming traffic is denied by default. So I can explicitly allow ports like SSH, I can allow 22 port. For HTTP, I have to allow 80. For HTTPS, I have to allow 443. So that's how I can allow ports according to the incoming traffic. But by default, a security group, which is a firewall, denies all inbound traffic. We can add custom rules to configure which traffic should be allowed. Any other traffic would then be denied. So for instance, if I want to add a new rule where I am going to allow every traffic that is coming from port 80 or 443. So that virtual firewall will allow every traffic that is coming from port 80 and 443. Rest of all the traffic would be denied then. So a security group is actually a virtual firewall, and with the help of that firewall, we can control inbound traffic coming towards our EC2 virtual machines. What is an internet gateway? As the name says, the gate to the internet. Internet gateway enables communication between a VPC and the internet. So we can use the internet gateway to allow communication of our resources in a VPC with the internet. So it acts as a bridge, allowing resources within the VPC to access the internet and vice versa. And similarly, our resources are exposed to the internet as well. It supports IPv4 and IPv6 traffic. So for instance, if I am running virtual machines in a VPC and I want to have those virtual machines publicly accessible by me, okay, by my team, by the other DevOps engineers, so I have to use internet gateway with my VPC. With the help of that internet gateway, my virtual machines would be accessible over the internet. Now, guys, what is a network ACL? We have already gone through about security group. A security group is a virtual firewall, but a network ACL is also a virtual firewall. Network ACL stands for Network Access Control List. Now, what is the difference between a security group and an ACL? That is one of the important questions we must know. The difference between security group and access control list. Though both are firewalls, a security group is also a firewall. ACL is also a virtual firewall. The difference is security groups work on EC2 level and ACLs work on the subnet level. That is actually the key difference. A network ACL is a virtual firewall that controls inbound and outbound traffic at the subnet level. And if I go back to security group, the inbound and outbound traffic is controlled for an Amazon EC2 instance. So security groups work on the instance level. We can control the inbound and outbound traffic on an EC2 virtual machine or EC2 instance level. But if we want to go more deeper and want to secure our infrastructure, I can control the inbound and outbound traffic on the subnet level as well. And that is known as access control list. Security groups work at instance level while ACLs work at the subnet level. That is actually the key difference between security group and access control list. Security groups are stateful while ACLs are stateless. So it is also one of the major differences between security groups and network ACLs. Security groups are stateful, whereas ACLs are stateless. Stateful, those protocols or those applications that retain the data, that retain the information. Whereas stateless applications or stateless protocols are those applications or protocols that do not retain any kind of data, that do not contain any kind of information. So this is also a difference. Security groups are stateful, whereas network access control lists are stateless. Now here is the graphical representation of ACLs. So you can see here, I am the client, I'm using a web browser, and I have initiated a request with the help of packet, and I am on internet. Okay, I'm a user using internet and I have just initiated a request. That request will receive the internet gateway. Internet gateway will open and it will allow my packet, my request, and it will reach the subnet level, network access control list. Now this is how we control our traffic on the subnet level. My virtual machines are located here, okay? And here I have the security groups that are working on EC2 level. So it means that subnet level is more superior. ACL is more secure as compared to security groups, okay? Because ACL, they work on the subnet level. So I can control the traffic from here as well. I can allow or deny the traffic using ACL, and then if I explicitly allow any type of traffic, then after going through the ACL, it will reach the security groups and then it will reach to my EC2 instances. So it means that ACLs are more secure as compared to the security groups. ACLs work on the subnet level, and if I want to deny any kind of traffic, it will never reach the virtual machines in my public subnet. So that's how ACLs work. You can see I'm the client, the request is initiated, it reaches the internet gateway, and after that, access control list will decide whether to allow or deny my request. So that's how ACLs work on a subnet level. And after that, the request is allowed, it will reach the security groups, and then security group will further allow my request to reach to the EC2 instances. So that was actually behind the scene how a request reaches the EC2 instance. Alright guys, after that we have virtual private gateway. Virtual private gateway is also known as a VPN in AWS. It is used for establishing a secure VPN connection between our on-prem network with our AWS VPC. So guys, let me explain it with that example. This is my virtual private cloud, and I am sitting in my on-prem data center. I want to access the resources on my virtual private cloud, but I want it to be secure as much as possible. So I can use virtual private gateway, and that virtual private gateway will create a VPN connection, a secure connection between my system and VPC on AWS. So it will be a secure tunnel where I can securely access my resources on AWS VPC using my laptop in my on-prem data center. So it is actually a VPN, and it creates secure tunnels. It creates secure connection between the on-prem users and the resources on AWS VPC. It provides secure and reliable communication between on-prem network and VPC. So the connectivity between the on-prem infrastructure and the VPC infrastructure would be secure. It would be in a secure tunnel using virtual private gateway, which is actually a VPN on AWS. In AWS, virtual private gateway acts as a VPN to encrypt traffic and mask IP addresses. So the IP addresses will also be hidden, and my traffic, my request packets would be encrypted for security. So that is actually virtual private gateway. It is actually a VPN on AWS to make it possible that the communication between on-prem users and the resources on AWS VPC is secure and encrypted. The IP addresses are masked as well. Now, what is a VPC peering? If you have gone through my Azure Fundamentals course, we have already discussed VPC peering there as well. So VPC peering, peer means friend. Peer means a connection. So if I want to merge, if I want to combine two different VPCs, two different virtual private groups, that is known as VPC peering. So the resources in VPC A can talk to or can communicate with the resources in VPC B. So VPC peering establishes a direct network connection between two virtual private clouds. In VPC peering, multiple VPCs are connected to form a single network. Now, VPC peering is not limited to only two virtual private clouds. We can have multiple VPCs, and they are combined together to create a single network. In VPC peering, EC2 instances of VPC A can easily communicate with the instances of VPC B. I have already given this example. Now, what is AWS Route 53? It is also one of the most common AWS services to register our domains. DevOpsMolvi.com. I can use AWS Route 53 to register this domain, full quality domain name on AWS using Route 53. And though I I have not registered DevOpsMolvi.com, but I am planning to register it on AWS Route 53, which is a DNS service, and it is used to register new domain names or transfer domains to AWS, abc.com, web.com. So we can register our domains using Route 53. It can handle a large volume of DNS queries without performance degradation. So it means that we can also use the name servers of AWS to resolve our domain, okay? Just like other websites that provide name servers or resolvers for our DNS queries, I can use Route 53, and I can use this service to resolve my DNS queries. Route 53 can monitor the health of our resources and automatically reroute traffic away from unhealthy resources, ensuring high availability. Now, this is an added benefit of Route 53. Route 53 keeps an eye on the healthiest resources within our infrastructure and routes the traffic only to the healthy resources to avoid performance degradation for our end users. It reroutes the traffic to the most healthy resources in our AWS infrastructure, and it ensures high availability for our end users. By the way, the most common use of AWS Route 53 is to register new domains, to transfer new domains to AWS, and to serve the DNS queries. Because 53 is actually the DNS port number, 53. And that's why this service is known as Route 53. After that, guys, we have AWS CloudFront. We already discussed it in our previous chapter in AWS Global Infrastructure. AWS CloudFront are actually the edge locations, the data center that serve the cached copies of our content to avoid latency, to avoid delays. Okay. AWS CloudFront is a content delivery networking service. CloudFront consists of edge locations. Edge locations are actually the data centers, which are geographically diverse data centers. Sorry, my bad. These are geographically diverse data centers that bring the content closer to users and reduce latency. I've told you latency means the delay. I want to open DevOpsMolvi.com. I want it to open as fast as possible, okay? Within few milliseconds. So to avoid delay, to avoid latency, I must have the cached copy of the content and application that are closer to me. So that is actually the purpose of CloudFront. CloudFront brings the cached copy of the content in a location which is closer to the user so that the users do not face any kind of delays or latency. Google also ranks those websites that load faster, that have the minimal latency, and they are ranked on Google. So reduced latency and faster loading times for users is possible with Amazon CloudFront, and Amazon CloudFront is a service that consists of edge locations. Edge locations are actually geographically diverse data centers that AWS has built around the world so that they serve the content nearest to the user's location. But how it is possible? That was the question in my mind as well. How the application that is actually running on my PC2 virtual machine is served with minimal latency. So we have to go through this diagram. I am the client and I am going to access my application, DevOpsMolvi.com. So DevOpsMolvi.com is resolved with AWS Route 53. And after the domain is resolved, my request is pushed back to me, and then it is reinitiated and it is redirected to Amazon CloudFront. Now, Amazon CloudFront lies on top of the load balancer. Load balancer is actually the endpoint where my application is being served, and load balancer runs on top of the autoscaling group. Autoscaling group consists of one or more EC2 instances with my applications, and all those EC2 instances get a balanced amount of traffic using the application load balancer. Application load balancer is the endpoint where I can access my application, but the cached copy of the content, the cached copy of my application would be served using Amazon CloudFront. Now, this Amazon CloudFront would be a data center that would be near to my location. It can be like in Mumbai, which is the nearest location. It can be in UAE, Dubai, which is more near as compared to US East 1. I am going to access my application that is running on these EC2 instances with minimum delays, with minimum latency, with the help of Amazon CloudFront. So that's how our application is accessed with minimum delays, with super fast loading times, and it is all possible with Amazon CloudFront. because Amazon CloudFront is an education, a data center that contains cached copies of our content, and it serves our applications with faster loading times and minimum delays. So that's it guys for today's lecture. I hope that you have got many concepts cleared regarding AWS networking. We have discussed VPC. We have discussed all the components of VPC like subnets, public and private subnets, virtual private gateway, internet gateway, security groups, network access control lists, and Route 53. And after that, we have discussed again Amazon CloudFront. So these are actually the core services of AWS networking. Still, if you have any question, feel free to ask. And in the next chapter, we are going to discuss AWS storage and storage services. See you in the next chapter. Have a good one. And if you have any feedback, please let me know. Thank you. Bye. Hey guys, I hope you're doing great today. This is our chapter number 7, and today we are going to discuss one of the most popular service, which is AWS Storage. AWS Storage provides unlimited storage that can meet our business needs. But there are certain and different types of storages that we must know when we are going to take the exam of AWS Cloud Practitioner. So we are going to discuss all the types of storage that AWS provides. Also, we are going to have a quick look on AWS storage classes. Okay, there are around 7 different storage classes that are aligned with our business needs that AWS offers. So what are the types of storages that AWS has to offer for us? Let's discuss. And before we proceed, usually that I say to you and request that please make sure that you subscribe DevOps Molvi. I really appreciate and need your support. So what is instance store? This is actually the first type of storage. Instance store. Instance store is an ephemeral storage type. Now, again, what is ephemeral storage type? If you remember my Docker lectures, or if you have watched my Docker lectures, we discussed ephemeral storage in detail. My brothers and sisters, ephemeral storage is actually a temporary storage. Okay, when our Docker container is running, the data will persist on that container. But if we stop or terminate the container, the data on that container will be lost. That's why it is not a permanent or persistent storage solution. That's why it is known as ephemeral. Ephemeral is actually a temporary storage. And in the same context, here, data is lost when the EC2 instance is stopped, terminated, or fails. Okay, instead of container, now let's consider EC2 instance. And if that EC2 instance has instance store, which is an ephemeral storage type, if we accidentally stop or terminate the instance, then the data on that EC2 instance would be lost. That's why it is known as a temporary or ephemeral storage type. In AWS, instance store is best suited for temporary data. It is not at all recommended for our production environments. Okay, we can face a lot of data loss if we are using instance store for our production environment. So therefore, it is for temporary data. It can be used for caching, okay, that we remove occasionally on from our servers, and high performance workloads where data loss during instance termination is acceptable, where we can accept that, okay, no problem, we can lose our data, it is not that important, these are just cache files or log files, whatever. So if we think that we can bear the loss of the data, then we can use instance store. But if our system is production environment, and if we are building our applications for our users where data loss cannot be tolerated, then we must go with Elastic Block Store, which is our next slide, and it is an alternate solution of Instance Store. Instance store is temporary. Instance store is ephemeral. Therefore, we need a permanent and persistent storage solution, which is our next slide, and it is Elastic Block Store. EBS volumes. Usually, these are known as EBS volumes. But what is Elastic Block Store? Instead of ephemeral or temporary, Elastic Block Store is persistent. It is a permanent storage solution where we will never lose our data. Okay, I hope that you understand it. It is known as EBS volumes. EBS volumes provide persistent network attached block storage. We can attach our volumes through the network with our EC2 instances. That's why these are known as network attached, and these are elastic. We can attach or detach with our EC2 instances. EBS volumes are ideal for long-term data storage and applications that require data persistence. We need data persistency, okay? And therefore, we must use a permanent and persistent data storage solution, which is Elastic Block Store. If we stop or terminate an EC2 instance, all the data on the attack EBS volumes will remain available. This is actually the core benefit of Elastic Block Store, and therefore, guys, we can use EBS volumes for our production EC2 instances because we are not afraid of losing our data. Our data will be persistent, it would be permanent, and it would be a long-term storage until and unless I myself remove the data or remove or delete the volume. Now, guys, here I have shared two different diagrams. Now you can see this is instance store. If the EC2 instance is running and the instance store that is attached with that EC2 instance will have the data as long as the EC2 instance is running. But if we stop it or terminate it, the data will be lost. And instead, in Elastic Block Store, you can see that the EC2 instance has been terminated or it has been stopped or it has been deleted, but still we have the volume with all the data in that volume. Okay, so that's why for production or QA or even dev environments, we must use Elastic Block Store because it is a permanent and persistent storage in Amazon Web Services. And after that, guys, we have Amazon EBS snapshots. And this is an additional layer to back up our critical data. Data is everything. Since I told you that data is the business revenue, data is money in this IT era. Okay, so we must take care of our data, and we can take incremental backups of EBS volumes by creating Amazon EBS snapshots. Now, what is an incremental backup? Incremental backup, I will show you with the diagram so that would be more easy. By the way, the definition of incremental backup is that the first backup taken of a volume copies all the data, and for subsequent backups, for more backups, only the blocks of data that have been changed since the most recent snapshots are backed up. Okay, only the changes are backup, not the full backup is taken every day. Okay, and now you can see in this diagram I have this EBS volume. Okay, and on day one I will have the full backup of that volume, and with the subsequent days, day 2, day 3, day 4, if there are any changes made in that volume, only those changes will be backed up. Okay, now that is why it is known as incremental backups. Instead of taking the full backups daily again and again, no, only the changes are backup. We have only one full copy that was taken on day one. I hope that you understand it. This is actually the difference between full backups and incremental backups. In full backups, we take the full backup on a daily basis. And in incremental backups, we take the full backup on day 1 and with the subsequent days on day 2, day 3, day 4, day 5 and so on, only the changes are backed up. That is why these are known as Amazon EBS snapshots. These are actually incremental backups, and we must have these backups in case of any volume getting corrupted. We must have our volumes backed up using EBS snapshots. All right, guys, now talking about the world's most favorite and world's most popular storage solution, which is Amazon S3, AWS S3, known as Simple Storage Service. S3 is a service that provides object level storage. Now, what is object level storage? From that, I mean to say, object can be an image, it can be a document, it can be a video, it can be any configuration file, a log file. All these are objects. That's why it is known as object level storage. In object storage, each object contains data, metadata, and a key. It means that every object will have, every image, every video, every document will have the metadata and a key. The data can be an image, okay? It can be a video, your personal videos as well. You can have text, document, configuration files, log files, or any other type of files. We can store them in Simple Storage Service. Metadata contains information about what the data is. It is data about data. Metadata is actually data about data, how it is used, what is the size of the object, when this data was uploaded, and so on. So it is actually metadata. An object's key is its unique identifier. Okay, each object will have a key, and it is its unique identifier to identify any certain object in Simple Storage Service, where we can have thousands of objects, thousands of images. We can identify each image with a key, and each object's key is its unique identifier. Amazon S3 offers unlimited storage, okay? And what is the maximum file size? Now, it is an important question. What is the maximum file size of an object in S3? And the answer is, it is 5 terabyte. So each object or each file can be up to 5 terabyte in Simple Storage Service. So guys, now what are the S3 storage classes? S3 has classified storage according to 7 different classes, okay, to meet our business needs. These are curated according to our business requirements. So there are actually 7 different storage types, and we can choose the storage type of our choice according to these 2 following factors. We have to keep these factors in our mind before choosing the storage class. How often we plan to retrieve the data? From data retrieval, I mean to download the data, okay? How often we are planning to download the data? Is it frequently or infrequently, weekly, daily, monthly, yearly, okay? And how available we need our data to be. So these are actually 2 factors, and then we can decide which storage class will meet our business needs. And there are 7 storage classes. The first one is S3 Standard, which is the most common one. And it is designed for frequently accessed data and stores data in a minimum of 3 availability zones. So it means that our data will be copied in 3 different multiple availability zones for durability, and we can access our data frequently. So if I am going to access my data and I want my data to be available every time I want to access it, I must choose S3 Standard, and my data would be replicated among 3 different availability zones to avoid data loss or data corruption. Now we have S3 Standard Infrequent Access. As the name says, ideal for infrequently accessed data with lower storage and higher retrieval price. the data that I want to access after a year, after 2 years, then the price of the storage will be lower, but the data downloading price, okay, higher retrieval price means the downloading price of the data would be a little higher in S3 infrequent access, but it is recommended for data that is infrequently accessed. I mean, after a year, after 6 months, after 2 years, etc. Number third is S3 one zone infrequent access, and it stores the data in single availability zones. Okay, so that is why it is known as one zone infrequent access. S3 intelligent tiering, ideal for data with unknown or changing access patterns. The data can be different. Sometimes it can be images, sometimes it can be videos, sometimes it can be documents. So the data is changing its patterns. There are different types of data. So for that purpose, I should go with S3 intelligent tiering, which is ideal for data with unknown or changing access patterns. And after that, guys, we have S3 Glacier Instant Retrieval, which is best for archived data that requires immediate access. And then we have number 6, S3 Glacier Flexible Retrieval, best to retrieve objects within a few minutes to hours. And then we have S3 Glacier Deep Archive, lowest cost, ideal for archiving and able to retrieve objects within 12 hours. First of all, Glacier is used for archives. If I have large data archives, then I must go with S3 Glacier. Then S3 Glacier has more three types, okay? There are three different types. The first is instance retrieval. If I want to retrieve, I want to get or download my archived data immediately, then S3 instant retrieval, as the names are actually defining the classes. And if I want it to be flexible, okay, take your time, then S3 flexible retrieval. But if I don't worry about time, it can take up to 12 hours to retrieve or download the data, then I must go with S3 deep archive, which is most cheaper storage class in S3. So these are actually different storage classes, and we are asked about questions that which one would be best for our business needs. So we must know about these storage classes in simple storage service. And by the way, most of the times as a DevOps engineers, we are going to use S3 standard. After that, guys, we have Amazon Elastic File System. Elastic File System is a shared storage in which a large number of services and resources need to access the same data at the same times. So just like we saw a shared drive, okay, in our university, in our labs, we saw a shared drive that we can all the students can access that shared drive to get the data, to get the presentations, get the lectures. Similarly, we can create a file system, elastic file system. If I want to share the data with my colleagues, with my DevOps teams, then I can use elastic file system, which provides a simple, powerful, and scalable solution for sharing and managing files in the cloud. Okay, and then all those files, all those documents would be accessible by my DevOps team, by the whole employees of the company. We can use elastic file system. Like I have given you the example of a shared drive. It is also a shared drive in the cloud. Okay, that is more easy to understand. And when we create an elastic file system folder or directory, then we can easily share our files, documents with all the employees, with colleagues in our IT company. And I have explained it here as well. In file storage, multiple clients such as users, DevOps team members, applications, servers, and so on can access the data that is stored in shared file folders. So those folders with the data are shared using elastic file system, and when those folders are shared. Everyone, every user, application, or servers can access those shared folders. So that's it, guys, for today's lecture. We have discussed instance store, EBS volumes, elastic block store. We discussed about simple storage service and all the 7 storage classes of S3. And after that, we had a quick look on elastic file system to share our folders, to share our data among our users and team members. So these were different storage types and storage solutions that AWS offers. I hope that you have got all your concepts clear. And in the next chapter, we are going to discuss about AWS databases. So I really appreciate that you subscribe DevOps Molvi. I will see you in our next chapter of AWS databases. If you have any questions, feel free to ask anytime. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 8, and today we are going to discuss about the databases on AWS. But guys, let me tell you that all the lectures are available in the description of each video. So I would recommend that you must see the description. I have been pasting the slides in the description of each video. This is actually my drive. AWS is awesome, and this would be our full AWS Cloud Practitioner course. And we have just 3 chapters left: security, monitoring, pricing, and support. But today, let's discuss about the AWS databases. And I will just start the slideshow. And starting with relational database. What is a relational database? Before understanding the AWS databases services, we must know about what is a relational database. A relational database is a way of structuring information in tables, rows, and columns. Normally, most of the databases that we see in our daily jobs and daily routines, these are most of the times relational databases. Why? Because these databases have tables. These databases have rows and columns. So proper structured databases with tables, rows, and columns are known as relational databases. And why these databases are known as relational databases? Because the data inside that database in columns, in rows, and in tables are related with each other. And due to their relationship with each other, the database is collectively known as a relational database. Each record in the database would include data for a single item, such as product name, size, price, and so on. For instance, if I have an e-commerce store where I am selling t-shirts, so I must have a database where I am storing the data about my t-shirts that are available on the store. Now here the product is t-shirt. The size, small, medium, large, and the price of that t-shirt. So we have all the information stored in the database. The information is related to other pieces of data. That's why it is known as relational database. Now what is AWS RDS? AWS RDS, which is Relational Database Service, is the world's most famous database service known as Relational Database Service. It provides affordable relational databases in the cloud that is easy to use, and also it facilitates us in creating database instances as per our requirements and DB engines. Now, there are different DB engines that are offered in Amazon RDS. So Amazon RDS is the world's most famous database service provided by AWS, and we can use multiple DB engines to launch our DB instances on AWS. What are those DB engines? What are the database engines? I mean, I can use Amazon Aurora, Postgres, MySQL, MariaDB, Oracle Database, and Microsoft SQL Server. So all of these are database engines, and I can launch the database instance with the engine of my choice. For instance, if I want to launch a DB instance with MySQL or Postgres, I have the option to do so because all those DB engines are available on Amazon RDS. Now let's have a quick look on Amazon Aurora, which is a SQL database, structured query language database. Amazon Aurora is an enterprise class relational database, and it is compatible with MySQL and Postgres relational databases, and it is up to 5 times faster than standard MySQL database and up to 3 times faster than standard Postgres databases. So Amazon Aurora is actually the product of AWS, and it is faster, 5 times faster than MySQL and 3 times faster than Postgres. So it is also a relational database or SQL, structured query language database, but as compared to prices with MySQL and Postgres, this database engine is super costly. Okay, it is costly because it is for production environments where we are looking for super fast speeds, and therefore Amazon Aurora is 5 times faster than MySQL and 3 times faster than Postgres. And for NoSQL, non-structured query language, SQL, we have Amazon Aurora. NoSQL, we have Amazon DynamoDB. Amazon DynamoDB is a serverless NoSQL fully managed database service. It is, first of all, it is a serverless database. It is NoSQL. So it means that it is non-relational database, and it is fully managed by AWS. A common example of non-relational database is key value pairs. And now what is key value? You might have seen while tagging, okay? Tags. For instance, if I have an EC2 instance, then I can use key value pairs to store multiple informations about that EC2 instance. Name, name of the instance. IP, the IP address of the instance. Zone, the availability zone of the instance. Security group, the security group attached with the EC2 instance. So these are keys and these are values. So the DynamoDB is best for key value pairs. With key value pairs, data is organized into items, keys, and all the items have attributes, their values, like I have given you the example of EC2 instance. And also when we use tags, we use key value pairs to tag our EC2 instances, to tag our clusters, etc. As the size of the database shrinks or grows, DynamoDB automatically scales to adjust for changes in capacity while maintaining consistent performance. Now, this is one of the most beautiful features of DynamoDB. If the size of the database grows, then we get more capacity, we get more resources. And if the size of the database shrinks, okay, it shreds, then the database automatically scales down. So there would be no performance impact whether the database grows or shrinks. So this is how DynamoDB works. After that, guys, we have Amazon Redshift. Amazon Redshift is a petabyte scale cloud data warehouse service. A petabyte is equal to 1024 terabytes, and it is used for data warehousing. It is used for large-scale big data analytics, and it offers the ability to collect data from many sources and helps us to analyze the data. If we have terabytes of data and we want to store it, we want to work on that data, we want to analyze it, then Amazon Redshift is the best service for the data up to petabytes. Petabyte means 1024 terabytes of data. And it means that we are going to work on an enormous amount of data. Then we must go with Amazon Redshift. And there are more database services from AWS like Amazon DocumentDB. It is a document database service. Amazon Neptune. It is a graph database service. Amazon Quantum Ledger Database. It is a ledger database service for ledgers for bankings. And we have Amazon Managed Blockchain, which is a blockchain network services. So there are different database services, not only DynamoDB or Aurora. We have these database services offered by AWS, DocumentDB, Neptune, Quantum Ledger, and the list does not end here. We have more database services like Amazon Elasticache, which is for caching, and it is a database cache service. Amazon DynamoDB Accelerator DAX, it is an in-memory cache for DynamoDB. And we have Amazon Database Migration Service. If I am looking forward to migrate my database to AWS, then Amazon Web Services offer DMS, which is Database Migration Service. So these are actually different database services offered by AWS, but we must have a little overview or a brief knowledge about each database service for our AWS Cloud Practitioner exam. And that's it for today, guys. It was a little short and sweet lecture. I hope that you have a clear picture of AWS databases, the difference between relational and non-relational databases, SQL or NoSQL. For relational, we have Amazon Aurora. For non-relational, we have Amazon DynamoDB. And for large data warehousing, we have Amazon Redshift. And then we have other database services that we have just a little knowledge, a basic overview or a basic definition of these database services. I will see you in my next chapter of AWS security, and where we are going to discuss about the security services that are offered by AWS. Make sure that you subscribe DevOps Molvi. Have a good one. Bye. Hey guys, I hope you're doing great today. This is our chapter number 9, in which we are going to discuss about security. Guys, in the previous lectures, I have already told you that security is one of the major concerns of every IT organization. They want to secure their infrastructure. They want to secure their resources that we are going to build on any cloud platform. It's not about AWS specific. Whether you are going to build your infrastructure on GCP, Azure, or Oracle Cloud, security plays a crucial role. And therefore, AWS also provides security services so that we can use those services to protect our infrastructure, to protect our resources that we are going to build on AWS. So what are those security services? Let's discuss them one by one in today's lecture, and make sure that you have subscribed DevOps Molvi. I really appreciate your support. So first of all, we must know about identity and access management, AWS IAM, which is the most important service while we are talking about security. IAM manages users and their access to AWS accounts and services. So with the help of identity and access management, we can create users, we can create roles, we can create policies, and we can assign those policies, roles to the groups and users. It keeps our data safe and helps us control who can access our AWS resources and what they can do with those resources. If I am creating a user, okay, on AWS using identity and access management, it means that I have the authority to assign specific permissions to that user. That user can only view the resources. That user can only modify the resources. So these are permissions that we can assign with the users. We can give them administrator role as well, but it is not recommended at all. AWS security works on the least privilege principle. We must go with the least privilege principle, that we must give the least permissions to any user that he or she needs. We can create users, groups, roles, and policies using identity and access management. We have the option to create a user. We can grant permissions or roles with that user. We can also add that user into a group. So we are going to discuss each term one by one. But first of all, we must know what is an AWS account root user. When we log into our AWS account with root user after signing up on AWS, whenever I create a new account on AWS, I sign up with the help of email address and password. Okay, when my AWS account has become active, then this would be my root user. The email address and the password. This would be the root account on AWS. So that root account have all the permissions, have all the privileges to create whatever that account wants. So root, just like on Linux, root is a super user. Similarly, on AWS, root account is the super user account. The root user is the super user in AWS with full access. It has everything. It has full administrator access on all the services, on billing as well. To all the services and resources in the account, we can create IAM users with the help of root user. Just like on Linux, guys, when we sign in with the help of root user, the next step that we do is to create another personal user. For instance, I will create a DevOps Molvi user. That user will be privileged with sudo access, okay? And I will never use root accounts to log into my server to protect my root credentials. That is one of the security practices that is observed. Similarly, in that case on AWS, after signing in with the root user, we must never use root account again to protect the root credentials. So we must create a new user. I can create a new user, and then I can give all the necessary permissions like administrator access as well. And then I can create more users for my team and more groups, roles, and policies for my team as well. So we must protect root account and we must not use root credentials every time. After logging in with the root user, then we must create a new user with the administrator access. We must protect root account. So what is an IAM user, identity and access management user? Just like we normally create users on Linux, okay, we can create users on AWS, and that user is known as identity and access management user. An IAM user is an identity that we create in AWS. It represents the person or application that interacts with AWS services and resources. IAM user is the only way we can interact, we can create, we can modify resources on AWS. But by default, when we create a new IAM user in AWS, it has no permissions associated with it. When I create a new user, new IAM user, it does not have any permissions. So that's why, being the administrator myself, I can assign the necessary or the required permissions with that user. For instance, that user only needs access to S3, simple storage service. I will attach only the necessary permissions of S3 with that user. For instance, if a user B needs to have access to EC2 only, then why should I give him or her access to other services? I will just go with EC2 permissions and I will attach all the necessary EC2 permissions with that user. And therefore, whenever we create a new identity and access management user on AWS, it does not have any permissions. And then we can assign the required or necessary permissions with that IAM user to perform certain tasks. Now, what is a group in AWS IAM? Just like on Linux, we know that there are certain groups like Docker group, okay, like sudo group. So we can add the users in these groups, right? Similarly, a group is a collection of IAM users. Multiple users in a single group is known as an IAM group. Instead of assigning permissions to each user individually, we can put users in groups and assign permissions to the group. This makes it easier to manage permissions for multiple users at once. For instance, I am the DevOps lead and I am managing a team of 4 DevOps engineers. All those 4 DevOps engineers need permissions to the EC2 instances. They need permission to EC2 service. So I will create all those 4 users and I will create a group and I will attach EC2 permissions with that group. So by default, all those 4 users will inherit that policy because they are added into a group and that group has all EC2 permissions. So instead of assigning individual permissions to all those 4 users, I will do that. I will add those 4 users into a group and then I can assign permissions, roles, policies with that group. So all the users will inherit those policies or those roles permissions by default. So that is the purpose, that is actually the benefit of creating a group. For instance, if there are 100 users and all those 100 users need EC2 permissions, then what do you think? How much time will it take to assign permissions to each individual user? No, I will add all those users into a group and I will assign permissions to the group, and all the users within that group will have those permissions. That is actually the purpose of creating a group in AWS IAM. Now, I have been talking about IAM policy. What is an IAM policy? A policy is a document with defined permissions. All the permissions, like the permissions can be read only, view only, modify, administrator, write. These are all permissions that we can use in IAM. When all these permissions are gathered together in a document, it becomes a policy. Policies specify what actions are allowed or denied on which resources. For instance, if I define a policy where I am giving full EC2 permissions, administrator access of EC2. So it means that every action can be performed with EC2 instances using that policy. Those actions can be rebooting an EC2 instance, stopping an EC2 instance, or creating new EC2 instances. So all these permissions are gathered together in a document, and that document is known as IAM policy. Policies can be attached to users, groups, or roles. So we can individually attach policy to a user. We can also attach policies to groups, and my fellas, we can attach multiple policies with one user at one time. We can attach multiple policies with groups at one time. And we can also attach policies with roles. And I have given the example of an IAM policy which allows a user to list objects in S3 bucket. So with the help of that policy, a user A will only view what are the objects in that specific bucket. Okay, so he or she can only view the objects in that specific bucket. So if I attach S3 administrator, simple storage service administrator access with that user, so it means that now that user has all the permissions of S3, full permissions of S3, and he or she can now modify the objects. He or she can add more buckets. He or she can delete or add new objects into the buckets. So it means that that user has full S3 permissions. By the way, it is not recommended at all to give administrator access to the users, because I have told you in my first slide that AWS security works on least privileged principle. Give them the least permissions. Give them the only permissions that they need to execute their tasks. So that is what least privileged principle. So policy is a document which contains permissions, and we can attach policies with users, groups, and roles. And I have given the example of listing objects in S3 bucket. All right, now what is an IAM role? Identity and access management role. An IAM role is a set of permission. Just like we have policy, we have role. But there is actually a difference, and a role defines what actions are allowed and not allowed to be performed in AWS. A role is a set of permissions that can be temporarily assigned to entities like AWS services, EC2, Lambda, or even users from another AWS account. IAM roles use temporary credentials that expire automatically. So, guys, in order to understand role, let me give you a real example, a real use case. In the recent project, I was using two services on AWS App Runner and AWS Elastic Container Registry. I was using App Runner to deploy my application on AWS, a managed service. App Runner is a managed service, but that service actually needed access to ECR for Docker images. So therefore, I created a role and attacked that role with App Runner. And that role was having the permissions given to AWS App Runner that this service can access Docker images on ECR anytime whenever it needs. So it means that a role also contains permissions, but we can attach roles with services as well. Instead of users, we can also use roles to be attached with the services. We can attach roles with EC2 service. We can attach roles with ECR. We can attach with ECS. So a role is actually a temporary credential that is required to execute a specific task, and when that task is completed, credentials in that role automatically expire. So the key difference between a policy and a role is we can attach policies with users and groups. But as far as roles are concerned, not only we can attach them with the users, but we can also attach roles with the services as well, directly with services like EC2, App Runner, ECS, or S3. So that is actually the key difference between IAM policy and role. Both are set of permissions. Policies are assigned or attacked with users and groups, whereas roles are also attacked with users and groups, but also we can attach roles directly with the services. All right, guys, now what is an AWS organization? What if I have multiple AWS accounts and I have to manage all those accounts? With the help of organizations, it is possible. So AWS organization is used to manage multiple AWS accounts of a single IT company or organization. When an organization is created, AWS organizations automatically creates a root which is the parent container for all the accounts in our company. Multiple AWS accounts can be managed in a single organizational unit. So that organizational unit actually controls all the AWS account. So if we have multiple AWS accounts in our IT company, and being the DevOps engineer, I have to manage all those AWS accounts. So instead of managing them separately, I can create an AWS organization. AWS organizations create a root container, and with the help of that container, I can manage all the AWS accounts with the help of single organizational unit. So AWS organization is used to manage multiple AWS account for a single IT company. All right, guys, now what is AWS Artifact? AWS Artifact is a security compliance management service. AWS Artifact provides on-demand access to AWS security and compliance reports and select online agreements. An audit or inspection of those reports will ensure that the company has met the standards. All right, guys, now let's wind up this lecture and have a quick look on additional security services from AWS. So I will not go more deeper into the details, but we have Amazon Shield, which is used for protection against DDoS attacks. We have Amazon Inspector, which is security assessment and vulnerability scanning service. And we have Amazon Guard Duty, which is threat detection service. And we have Amazon WAF, Web Application Firewall, which protects web applications and APIs. And we have Amazon KMS, which stands for Key Management Service, and it creates encryption keys to encrypt data. So these are additional security services from AWS, but our focus was on IAM. And in the next course, we are going to have a deep dive in AWS IAM. That's it for today's lecture, and we are just 2 chapters away to complete our Cloud Practitioner course. Next chapter would be AWS Monitoring. I will see you in the next chapter. If you have any questions, feel free to let me know. Take care. Bye. Hey guys, I hope you're doing great today. This is our second last chapter of our AWS Cloud Practitioner course, and it is about monitoring. Guys, monitoring is one of the key responsibilities of site reliability engineers and DevOps engineers as well. We have to keep our resources up and running all the time. We have to be responsible for the alerts that we get from different monitoring tools that we are going to discuss in our today's lecture. I have worked as a systems administrator in server health monitoring department. And guys, this job looks easy, but it is one of the most highest responsible jobs in the world, because you have to act as soon as possible on every alert, on every incident that is reported from these monitoring tools. So, what is monitoring and what are the AWS monitoring tools we have? Let's discuss in this chapter, and make sure that you have subscribed DevOps Molvi. I really appreciate your support. So first of all, we know that what monitoring is. Monitoring means to monitor our infrastructure. I will just give a quick overview of monitoring, and you have to keep your eye on all the dashboards, all the screens that we have in our network operations center, which is known as NOC. So as a NOC engineer or a DevOps engineer, you have to keep your eye on all the dashboards. You have to monitor the incidents. You have to monitor the thresholds. You have to check out Slack notifications, email alerts, etc. So for that purpose, to monitor efficiently, to monitor all our resources efficiently, we have one of the best tool, which is known as AWS CloudWatch. Amazon CloudWatch is a web service used to monitor and manage various metrics and configure alarm actions based on data from those metrics. So first of all, it is a web service which is used to monitor infrastructure. We can monitor the EC2 virtual machines. We can monitor our S3 buckets, put requests, get requests, and then we can set certain thresholds, and when any of the resources which cross that threshold, we will get an alert based on the thresholds. So we can configure alarm actions based on the data from those metrics, and AWS services send metrics to CloudWatch. So when we are using CloudWatch, we have to add all the services that we need to monitor. For instance, if I want to monitor EC2 instances, then it is obvious that I am going to add EC2 service in my CloudWatch. So CloudWatch will get all the logs, CloudWatch will get all the data matrices from all the virtual machines running on EC2. So CloudWatch will gather all the data metrics, and then CloudWatch will help us to monitor EC2 virtual machines depending on that data. So any service that we want to monitor with the help of CloudWatch, we have to add that service to CloudWatch. Then CloudWatch will do the rest of the job. CloudWatch will get all the matrices, CloudWatch will gather all the data from that service, and then we can monitor our service EC2, S3, ECS, Kubernetes clusters based on CloudWatch, alarms based on CloudWatch dashboards. CloudWatch uses these metrics to create graphs automatically. There are graphs that CloudWatch, we are going to see those graphs and we are going to practically configure alarm in our solutions architect course. But for now, we must know that CloudWatch uses all the matrices of those services, okay, that CloudWatch gets from all those services and then creates beautiful graphs, and it makes us easy to monitor going through all the graphs that CloudWatch creates for us. Okay, what is now CloudWatch dashboard? The CloudWatch dashboard is used to access all the metrics of the resources from a single location. We can see all the graphs, we can see all the metrics, we can see the status of all the services using CloudWatch dashboards. For instance, if I want to create a dedicated dashboard for all the EC2 virtual machines on my AWS account, then I can simply go through that dashboard and see, okay, all the EC2 virtual machines are up and running and there are low performance degradation issues. So that's how we can use CloudWatch dashboard, and CloudWatch dashboard is a central point where we can see all the metrics, all the logs gathered in a single location. We can use a CloudWatch dashboard to monitor the CPU utilization of one Amazon EC2 instance or all the EC2 instances of our AWS, and we can see the total number of requests made to an AWS S3 buckets. So I can create separate dashboards depending on the services. Okay, I can have a separate dashboard for my EC2 instances. I can create separate dashboard for S3 buckets. I can create separate dashboard for storage, for CPU, for memory. So depending on the metrics and logs that CloudWatch collects from those services, I will have that dashboard where I can get all the information. And guys, after that, we have CloudWatch alarms. CloudWatch alarms provide continuous monitoring of our AWS environment. For instance, I have shared the example of an alarm alert when CPU usage on an EC2 instance exceeds a certain percentage, and we can receive notifications whenever an alarm is triggered. We used to receive notifications via Slack, via any monitoring tool like Zabbix and Nagios. I had used them in the previous companies, but we can set the threshold. For instance, if any EC2 VM, its CPU goes beyond 80%, then we must receive an alert. We must receive a notification that EC2 virtual machine ABC is now exceeding the CPU threshold of 80%. We have to check out this virtual machine and check out the errors. So this could be an example of the alarm that is triggered on a threshold that we explicitly set ourselves. And we can set all these alarms using CloudWatch alarms, and we can use other AWS services like simple notification service or simple email service to get the notifications or emails depending on the alarms that we configure using CloudWatch alarms. After that, guys, we have AWS CloudTrail. So we know we can monitor our EC2 virtual machines, resources, our AWS infrastructure using CloudWatch. But what is the difference between AWS CloudWatch and AWS CloudTrail? The difference is quite simple and straightforward. AWS CloudTrail is a service that enables auditing, security monitoring, and operational troubleshooting in AWS accounts by recording API calls and related events. Guys, if you are a Linux pro, okay, and you have worked on Linux operating systems, then you must know about the key monitoring files like warlog messages, warlog secure, warlog auth.log. These files actually contain all the monitoring logs, who has logged into our Linux server, what commands that user is running on our Linux servers. So these files actually contain all the logs of our Linux server. Similarly, CloudTrail records all the activities happening with our AWS account. Like for instance, who has logged into our AWS account, and CloudTrail records all the API calls and all the related events that are happening with our AWS account. The recorded info can be identity of the API caller, okay, the username, for instance, the IP address, the time of the API call, and the resource IP address of the API caller. So every activity that is happening with our AWS account is being recorded. That's simple definition of CloudTrail. CloudTrail records each and every activity, each and every event that is happening with our AWS account. So we can go through the AWS CloudTrail logs and information if there are any malicious attempts happening with our AWS account. So AWS CloudTrail records all the activities with our AWS account with the help of API calls, the time, the IP address, the username. Every activity would be recorded. In addition to that, we have CloudTrail logs API activity for our AWS account, which includes action taken in the AWS Management Console. Not only we can use AWS Management Console, we can also use AWS CLI and AWS SDKs and APIs. Every activity would be recorded whether we are using AWS Management Console or CLI or SDK or API. CloudTrail will record all the actions, it will log all the API calls, and we can go through all the logs and events that are happening with our AWS account. It also detects and responds to unusual API activity and potential security threats. Like I said, that if there are any malicious attempts happening with our AWS account, then AWS CloudTrail can let us know that someone has logged in from that IP or from that location. You must check it out. Okay, so that's what CloudTrail used for. We can use CloudTrail to monitor, to log all the activities that are going through with our AWS account. And lastly, guys, we have AWS Trusted Advisor. AWS Trusted Advisor is a web service which inspects our AWS environment and provides real-time recommendations in accordance with AWS practices. These recommendations can be cost optimization, performance, security, fault tolerance, and service limits. So if you remember, we had discussed about Trusted Advisor in Azure as well. The Trusted Advisor actually recommends the practices. Using those practices, we can secure our account, we can reduce our costs, okay, and we can also use those recommendations to protect our AWS infrastructure and account. So we are going to see AWS Trusted Advisor in detail in our Solutions Architect Associate course, but for now, we must know that AWS Trusted Advisor recommends certain practices, and using those practices, we can secure our account, we can optimize our resources, we can reduce our costs. So that's what AWS Trusted Advisor used for. And that's it, guys, for today's lecture. We are going to discuss our last and super easy chapter, which is AWS pricing and support. Make sure that you have subscribed to DevOps Molvi. I will see you in our last chapter. I'm super excited about that because we are going to finish up this course, and I hope that you have enjoyed this course thoroughly. I will see you in the next chapter. Make sure to subscribe and really appreciate your support. Have a good one. Bye. Hey guys, I hope you're doing great today. All right, we are going to wind up our AWS Cloud Practitioner course, and today we are going to talk about AWS pricing and support, and that would be our last lecture of AWS Cloud Practitioner certification course. And guys, you can see that I have already been planning and working on more AWS courses. And just like I promised, we are going to have our AWS Solutions Architect Associate course uploaded on our YouTube channel as soon as possible. So just for making you assured that I am already working and writing lectures on AWS Solutions Architect Associate on my Google Drive, and I would be recording these lectures and going to upload on YouTube channel DevOps Molvi as soon as possible. So that's why I would request you to stay tuned and make sure that you have subscribed DevOps Molvi. Today, this would be our last lecture of our AWS is Awesome lecture series, and we are going to talk about AWS pricing and support. We have covered almost 10 chapters so far, and I have been sharing the slides of each lecture in the description. So make sure that you must check out the description of each video. You will find the slides link in the description. And today we are going to have our chapter number 11, which is AWS pricing and support. And you can expect 3 or 4 questions regarding different AWS pricing models and support in the AWS Cloud Practitioner certification exam. So let's get started. And first of all, we have AWS free tier. We have already discussed AWS free tier in our first 2 lectures, and we have gone through all the possible details of AWS free tier. So make sure that you must check out the first 2 lectures in which you are going to find more detailed information about AWS free tier. The AWS free tier offers are available for 12 months after we create an AWS account. Some services are offered on a free trial. Some are offered on 12 months. Okay, you can enjoy the services for the next 1 year from the day you are going to create your AWS account, and some of the services are free for the rest of our life. So make sure that you must check out the first 2 lectures in which we have already covered AWS free tier. So free tier means that the services that are available free of cost. And we have AWS pricing calculator, which is an important pricing tool to calculate our infrastructure prices on AWS. We know that AWS works on pay-as-you-go model. Pay for the resources that we use. Okay, this is pay-as-you-go model. We have AWS pricing calculator, which gives us an estimate for the cost of building resources on AWS. Let me explain it real quick. For instance, if I am going to launch 10 large EC2 virtual machines, so I can use AWS pricing calculator to get all the possible costs of launching 10 large EC2 virtual machines, like storage, their CPU and memory resources costs, and elastic IP address cost. So we can get the rough estimate of all the pricings before we are going to actually launch any AWS resource. So before building resources on AWS, we can use AWS pricing calculator to have an idea of the costs. Okay, we can generate monthly cost estimates for all AWS regions as well. Guys, remember that AWS costs get varies. Okay, they are varied according to the regions. For instance, if I am getting monthly cost of an EC2 VM as $30 in Asia Mumbai, maybe it is more cheaper in US West region or US East region. So that's how the prices of the resources vary according to the regions. So using pricing calculator, we can also get the estimate of the costs according to the regions. For instance, if I want to have all the estimates of the cost of AWS resources according to the Mumbai region, then I can use AWS pricing calculator. AWS has shared the prices of all of its services. There is nothing, as we can say, hidden from us. AWS has shared every cost, every price of its service on AWS. We have all the costs, we have all the pricings of each and every service on AWS official websites. So there is anything we can say that it is hidden from us, okay? And we have AWS Billing Dashboard. We can compare current month-to-date balance with the previous month and get a forecast of the next month based on the current usage. Okay, so for instance, if I have bills and I'm running resources on AWS, I can get the estimate of the current month. I can get the previous month's cost as well, and I can get the estimate of the next month. What would be the cost? What would be the bills that I am going to expect in August, in September, in November, etc. So we can also compare the costs. We can also get an idea of the usage in the previous months and in the future or the next months with the help of AWS Billing Dashboard. And also, guys, we can view month to date spent by service. Okay, now for instance, today is 22nd of July, and I can use from 1st of July to the current date, and we can get the estimate of from the 1st of every month to the current date. We can view free tier usage by service. We can access Cost Explorer and create budgets. We can also purchase and manage savings plans, and all of that is available in AWS Billing Dashboard. So what are actually budgets? We are going to discuss it in our next slide. Now, what is consolidated billing? Consolidated billing means, it is simple by the way, to receive a single bill for all AWS accounts in our organization. In our organization, we have 10 or 12 AWS accounts, but I want to have a single bill for all those 10 or 12 AWS accounts. I can use consolidated billing, and I will get only one bill of all my AWS accounts in our organization. The default maximum number of accounts allowed for an organization is 4, but it is possible to add more accounts in the organization to get a consolidated billing, to get the billing of all AWS accounts. We can easily track the combined costs of all the linked accounts using consolidated billing. Like discussed before, that we can have all the accounts added in our organization, and we can get a single bill of all the AWS accounts using consolidated billing. And after that, guys, we have AWS budgets. Like we can create budgets to plan the service usage. We can have service costs and instance reservations using AWS budgets. In AWS budgets, we can also set custom alerts when the usage exceeds the budgeted amount. This is pretty straightforward. Like I have given the example of setting a budget for Amazon EC2 not exceeding $200 for the month. This would be the budget that I'm going to set for EC2, that my EC2 budget should not exceed $200 for each month. And if it is going to exceed, I should get an email notification. We can also configure notifications if any of the service is going to exceed the defined budget. So with the help of AWS budgets, we can define the limited budget for any service in AWS. Like I can set $200 for Amazon EC2. I can set $50 for S3. I can set $500 for EKS or ECS. So I can create budgets using AWS budgets, and I can limit the usage with the help of budgets. Okay. And we can also set the custom alerts when any of the service is going to exceed that budget. I should get alert. I should get an email notification, and then I can check out and further investigate what was the reason of that service exceeding the limited budget. And after that, guys, we have AWS Cost Explorer. It is a tool to visualize, understand, and manage the AWS costs and usage over time. We have AWS Cost Explorer. It includes a default report for the costs and usage for our top 5 cost reoccurring AWS services. And also, I have shared the example of the same example that I have been sharing earlier, that monthly costs for Amazon EC2 instances. So, being a DevOps engineer, if I want to have all the details, I want to understand the cost usage by each service, then I can use AWS Cost Explorer. AWS Cost Explorer shares a detailed report of the top 5 services that have the highest cost for that specific month. So, AWS Cost Explorer includes a default report of the costs and usage for our top 5 AWS cost occurring services. And those services can be like EC2, S3, bandwidth, ECS, okay, EKS, and all the costs are combined in AWS Cost Explorer. And we can also see the cost of the previous months as well using Cost Explorer. So it shares all the monthly costs of our AWS services. And last slide, guys, we have AWS support plans as well. So there are actually different types of support plans, and AWS provides support according to the plan that is attached to your account. For instance, we have basic, we have developer support plan, we have business support plan for IT organizations, we have enterprise on RAM, and we have enterprise support plan. Among all these support plans, only basic is free. I can use basic support plan only, because all the rest of the plans like developer, business, enterprise, on-ramp, and enterprise, all of these support plans come with a price tag. So you have to pay additional price for the support plan. And among that, enterprise support plan is the most costly support plans. You can get more details of all these support plans on AWS website. So that's it, guys, for today's lecture. And we thankfully have completed our AWS Cloud Practitioner certification. And just like in the beginning, I have shared that I am already working on AWS Certified Solutions Architect course as well. Feel free to ask, and I will see you in our next course. Have a good one. Bye.